Analyst thing right now.
Yes, yes,
Search, LLM functions,
yes,
fine tuning, and
yes,
analyst. I think this is again just a dummy window, so we can just go about to this.
yes.
Just one thing I'm having for just in case if you want to share something else. Okay. All right.
Perfect.
Did you see my screen, correct?
Yes.
All right. So it's still there. So it's my um,
Of you for joining us here and making time for us during your weekend. My name is Lalita and I'm a data engineer at Anblicks. And yes, so today we have three speakers with us today.
I think I'm having some trouble hearing guys clearly. Like, is that something you're far away from the mic or a machine or something? I cannot hear clearly. Okay, no worries, no worries. So I understand, no problem.
Okay, you can start, Kamesh.
Alrighty. So let's go. Let me share my screen first and then get started from there. Okay. I hope everyone sees my screen. In case, just a little logistics before we get into the whole session, right? Some cases is the virtual one. Obviously, things get stuck. Uh, yeah, let me know if you can't hear me or if you see me going faster or you want to take a pause or something, ask questions or something. Then we can stop me. The better thing would be like I have series of things to share. Then I have demos clubbed in between them. So we'll be shuffling between the slides and demos. So if you have questions, probably I would definitely encourage that we park it at the last so that we can take those questions so that I can explain them without cutting the flow because I want to share quite a lot of things. It's going to be I should say, like an overflow for you when you go back. In case if you feel that you need more insights, more questions on these and all of the stuff, we will also share you the user forum link that you already are probably would be aware of that. You can post the questions there. And you can also scan the QR code that you see on my screen, which has all my socials where I'm most of the time active. Uh, Typically, I prefer LinkedIn, so you can just give a LinkedIn request connect and just do mention where you met me so that like I know like hey you are from this particular event or meetup or whatever it is, right? And we can continue our conversation there and then go from there, like if you want. As I said, you can also pop your questions just to ask Shubhangi. I think we can use a chat to pop the questions, or is there going to be live?
It's going to be like,
Okay. Yeah, that will be great. So I think you can also put that on the chat if that okay, Bansila, so that like we can have a track of that at the last. So I leave that choice to you. Like I think as far as like we can start that. So I think that is pretty much what I have. So the agenda for today is pretty much like this. So I'm going to walk you through all the GenAI stuff, what we call as Cortex in Snowflake world. Talk about what all features Cortex has, what it gives, what applications we have built, and why we want to use Cortex. And then I'm going to kind of gel that with few demos in between, so that you know what you can do with Cortex. Right? All this requires like we need to have a trial Snowflake account. If you're having a trial, just do make sure that you create the trial in AWS US West, because that's where all the features that I'm going to show today is available. Some other regions do have few features and few features are not available. So I leave the choice to you. So just whatever you want to try, you can just go try it in US West. Just do a trial account there and do that. All right. So so these are all few things. So how do we start in Snowflake, right? So we just gave like we have a unified platform for end-to-end Gen AI. So what I mean by that is like, so we have the topmost, the app development stack that we basically do all your development. It could be AI/ML Studio. I'll show what that is. We'll see some examples. When I run my demos, I'll be using notebooks. I'll also be using Streamlit to kind of connect to the services, GenAI services and other stuff. And also you'll see something about Copilot, which I can do right from my Snow side. So these are the what you call the very basic tools. That's the easy part of stuff, like where we have the no code, low code solution that we can technically take and start developing your AI ML stuff. So in fact, we used to call this as in seconds, right? Maybe like your organization is something which does not have very extensive AI ML experience, but you want them something to be get started, do a POC or proof of technology or proof of concept to see something is working and then start moving in and ramp up your resources and other stuff. Then that's the best place, right? You don't want to invest too much time doing all the mechanics of doing a Gen AI, writing code by yourself, etc., etc. And what are the Gen AI? So we have split two things, right? I said it's Gen AI and ML. So machine learning separately, and then generative AI is what is being done separately. All our generative AI stuff, it comes under what we call as Cortex AI. And then what we do, everything under machine learning, for example, forecasting, anomaly detection, and whatever the machine learning stuff that you want to do, everything comes under ML. So what we're going to see today is more around Cortex and Gen AI, right? So that's what we call. I keep using Cortex, which means that by default, you can just assume that that's going to be generative AI stuff that I'm talking about, right? And as we streamline our development and lifecycle, the very important stuff that also comes is like, so hey, what about my data, right? Because in Snowflake, we put security at the highest thing, right? So we always say that data and model governance using Snowflake Horizon on model registry. So what I mean by here is any data that you come inside or use it within generative AI. So it's not going to go back to the provider. The data is going to stay right within your Snowflake account and is governed by all our backs and other stuff. We'll talk a little bit more detail about that down the lane. So that's what we mean by model governance. And model registry is basically is used for machine learning stuff mostly, right? Where we want to store the model is like, for example, I create a code and I version the code and put it inside GitHub. And then I use another version, another version, another version, right? You just use semantic versioning kind of doing stuff. We can exactly do the same thing with machine learning as well, where I can create a model and then fine tune the model. That's the process of fine tuning, right? I can version the model and put it and use the version for it whenever you want to do that. You'll see an example of that when I show you a demo on document AI. That's where we'll use versions and then see, okay, how do I pick up the version? How do I use a version in my queries, right? So we are, again, as I said earlier, so we are just going to use three different stuff, right? We say, okay, we have talked about Cortex AI. It's all going to be easy, efficient, and trusted, right? That's our guiding principle. So what we mean that, like, we want to make things super easy, right? Either you are a Python developer, no worries. We have APIs for doing all these stuff using Python. And if you are an, for example, SQL guy, then we have things for doing SQL. And if you're a business user, then you don't have any knowledge of any programming language. You just know only plain English, but you want to derive data insights. Then we have the no code studio, which I'll show an example of what I mean by that. Everything is right now ready for you to get started with Gen AI in flash of a second. Right? That's what we call as easy side of it. And efficient, what do you mean by that? Like we are not giving you all the models that is available right now in the industry, right? In the globe, for example. So we choose cherry picked all the models which are efficient. They mean to say like the value for cost to money is very important there. So how much I spend on GenAI and what we give back with efficient result and easy to use. That's what we call as efficient state-of-art models and system design for enterprise use cases. That was the whole goal behind Cortex AI is that we are targeting enterprise use cases. We want GenAI to work with your data in enterprise within an organization. So we want to have some level of efficiency security, stability across the models. That's where we thought like, okay, let's do efficiency as one of the core principles for GenAI when you build these models. The next one is trusted. This is super important. What do you mean by that? Like, I don't want to give some crap or any unwanted information when I kind of ask questions to my LLM, right? So there are some standards that is set inside GenAI. Like it's still kind of what you call iterating and developing all these rules and all these security stuff that we talk about, all these ethics that we talk about. Everything is being modeled and improved. So we keep seeing that improvements also get guided into all our Snowflake Cortex stuff. So what we mean by trusted, so you don't get any unwanted information or unethical information or harmful hatred or whatever we call us, right? If you go to generic models and ask them questions right away, like they'll give you some crap answers, so which you don't want to hear. So that's where we call the trusted. We put them in what we call as guardrails. I'll talk about a section on security and trust at last. So that's going to be where we put everything together. So in a nutshell, so these are the three guiding principles: easy, efficient, and trusted. That's how we kind of drive all our GenAI stuff. These are our guiding principles. All right. So let's get into how Snowflake is making AI is easy, right? So this is the overall stack, which you could see in multiple different places. If you go to a documentation, if you go to a blogs, if you go to other places, then try to find out what they are. So this is how it looks like. So on the top, we see a couple of applications like Snowflake Copilot and Document AI. You'll see them in an example when I do a demo. So Copilot basically allows you to kind of generate SQL queries on the stuff and then give you that on the fly on within Snowside. We'll see an example of that. Document AI allows you to extract information from documents and build a model around it so that whenever you give a new document, it's able to extract information and give it to you. And all these are built on top of Cortex AI. Cortex AI is kind of, you can think like it's a heart of the whole Gen AI stuff that we do. So that's where Cortex, that's the reason why you see the entire box in Cortex AI. So we have Studio, we talked about that. And the other two things are more what we call as a conversation analytics, right? So mean to say like I want to interact or converse with my data and get insights. That's where Cortex Analyst and Cortex Search comes into picture. So we'll see two of them in detail down the lane. And the fundamental thing of everything is all our models, right? We right now have Snowflake's Arctic model from A121 Labs, NVIDIA, Meta, Mistral, Reka, and also we support Gemma as well. And what we did is like we classified the models into three different buckets: large, medium, and small. So large is like, which is a bigger context window. To people understanding what is a context window is where how many tokens get exchanged between your AI and yourself, as the provider and you, right? The bigger the context window, the better the model performance is. At the same time, the cost is also more. The larger models basically have bigger context window and they're trained to handle a lot of things, like it's more general purpose, right? And then we have a medium-sized models where Snowflake Arctic and other things comes into picture, where they are kind of like not trained as much as the bigger models, but they're trained more for efficiency. For example, Snowflake Arctic's efficiency is super high and it's built only for enterprise use cases. And instruct model in sense like it can do only take instructions. It cannot take images or other stuff to kind of extract data from that, right? And we have smaller models which are like trained very less. I will talk about fine tuning where the small model comes into the picture, which is the lowest of cost. So if you see large, medium, and small, you can also think another way that the cost is like high, medium, and low kind of stuff. Okay. And then that's where we are task specific and embed models. We talk about those things in a second again. And we have foundation models. We just talked about the models that listed on top of your screen. These are all the foundation models. And we'll see why we need fine tuning. So that's going to be the next one we'll see about. Okay. So why we say we're efficient, right? Because you'll be right now wondering. So we saw about how we are making things easy. And we also said like we want everything to be efficient, right? So why we call them efficient? Efficiency doesn't come only with the task that it does, but it's also how much smaller number of parameters that it takes and what is the performance that it gives for the parameters, right? Because there is always a computer is running behind the scenes. There's always some large amount of data manipulation that needs to be done before it actually gets back the response. So which means that your model should be efficient. And we have three different efficient models that we have built, typically targeting enterprises. This is not for, I think you can definitely use for your personal or other use cases, but these are more to work with your data, the enterprise data that you bring within Snowflake. So that is how it actually is designed for. So for example, Arctic LLM is going to be the large language model that is super efficient in handling instructs. We'll see some examples when I run the demo. This is going to be an enterprise-focused foundation model. So foundation models are the biggest drivers. We'll see a little bit more about them in a second. Arctic Embed is a state-of-art search model. So what you mean by search is that this is where when you want to go search information within your data, right? There needs to be some amount of in a natural language. I have to put that thing always, right? Whenever I say search or anything within this context, the whole next 1 hour is always going to be natural language. I'm not going to put any kind of code or something like that to do a search. I'm just going to use natural language to do the search. When that's going to be the case, then Arctic Embed, we need to kind of vectorize the data. We'll talk more about that, how Arctic Embed is used when we talk about RAG, retrieval augmented generation. That is again used in conjunction with LLM. So we want to have some kind of a state-of-art search model. If you see the right side, the graph that shows you how this model performs against its peers, right? For example, Gecko or OpenAI Embed, because we have to basically convert whole chunk of information, documents and other stuff, or word, text, characters into what we call as vectors, right? That's where the search is going to happen, where the semantic search and hybrid search is going to happen. We'll talk about them a little detail down the lane. And finally, Arctic Tilt, which is it's going to be used for the document data to kind of extract information from your documents. So that again is all these are fall under the Arctic family, because that's where using Arctic is where we drive efficiency, and we can split these models into multiple 3 different stuff where it can be used, right? Kind of against like LLM or embedding or document extraction, all right? And next one, we talk about trusted. So how do we bring in trust, right? When you use LLM, it's not just I'm going to use LLM. We're going to use LLM. We're going to say it's going to be trusted. Trusted, we need to say like we have Cortex God, Snowflake Horizon. We talked about that. We talked about model registry. So these 3 things may say like, for example, I have role-based access using Horizon, so which means that I can all the LLMs also comply with all the RBACs, all the ACLs, and all the other rules that you define, kind of governance rules that you define. It has to be adhered by the LLM data as well, which means the data is naturally protected. And your data never leaves Snowflake. That's something which you keep iterating every time, because that's one of the things people always ask when trying to take AI in enterprise. Will my data leave enterprise? No, not at all. It's going to be within your Snowflake account. All the processing will happen within the Snowflake account. The data is never going to go out unless and until you decide to take the data out, right? That's what we do. And content safety, that's where Cortex Guard comes into picture, where we say, okay, filtering harmful content from being generated. Okay, I don't want my LLMs or the LLM models apps that you develop to generate some nasty content. So you make sure that it's guarded so that like it doesn't generate those kind of content. Okay, that's where we talk about easy, what all the tools that we give to make things easy for Snowflake AI. And then we talked about efficiency, how our models drive efficiency. They are built for efficiency. And lastly, we say, okay, everything within Snowflake AI is going to be trusted, because we want to have trust whenever you do something with Snowflake. So that's what we do, right? Now we talked about all these 3 things, right? We say, okay, Snowflake, now we could have understand Snowflake Arctic is the most driving model, efficiency model. Other than that, we also support other larger, bigger models. I'll show you a list of models that we support. You can use any of those models when performing LLM operations within Snowflake, right? But now, okay, I have LLM, I have efficiency, I have Snowflake to give me everything trusted and things, right? Now, my question right now comes to me like, what are the use cases where I can apply LLM? So that's a very fundamental question. Everybody is using LLM, and I want to use LLM, right? But I want to take you to a little down the level, right? Usually, what happens in our industry is like whenever something new comes or something pretty nice comes, everybody follows the path, right? And I try to call out this because I used to speak about this in many of those other engagements or talk that I do, is that like don't try to go in a blind fashion way that okay, everything I'm using can be turned into LLM, because or everything can be used, for example, into microservices. So everything I can use can be going to serverless or whatever it is, right? So do the due diligence, mean to say like, okay, whether my use case will definitely fit my GenAI use cases. That's where I say again, the value that Snowflake brings you, right? So because like we have 3 different buckets, something which you can do in seconds, something you can do in minutes, something you can do in hours. So we'll talk a little bit more. It's kind of encompass the whole stuff. So if you're not sure whether my use case fits into this whole scheme of things, I want to do some kind of a POC on this. Then what you start with is like the some other things that I'm going to talk, little demos that I'm going to show you, is all helps you to get started. We have all the tools that is required for you to just get started, even without knowing anything about AI ML. So that's where our low code or no code solution comes into picture. So do the due diligence, understand if your use case really fits into LLM or generative AI and other machine learning, and then start applying them. So go a step-by-step procedures. Don't do a bulk and everything one shot, because Everybody is doing LLM. I want to do LLM. Sometimes we burn our fingers when we technically do that stuff. Okay, it's nothing to do with this particular session, but it's again my experience that I'm sharing with you. Always try to see, okay, if this particular thing is going to fit my use case, then I'll do. Okay, that's where the easy part of the whole Snowflake AI comes into picture. Whenever I want to try something with AI, me to say my use case could fit into it. Let me get it Snowflake, try to do the AI stuff that Snowflake gives me, do the POCs with this low code, no code solutions, make I'm understand if I'm achieving my efficiency and then do it. All right, great. So let's little detail into what are the use cases that they are mostly applicable. Okay, so these are the top thing, right? Automated BI, okay, business analysis with natural language. So this is where I was talking to you about when I was showing those easy blocks, right? The whole ecosystem of Snowflake AI. The very first thing we talked about is everything is going to be natural language, right? I want to do an automated BI, for example. Let me say, like, I come as a business analyst or somebody business user. So I don't have any knowledge of any technical stuff. I just know only English. Okay. And that's a case like where I want to interact with my data in a plain English and get insights, generate graphs, get all the data about it, like got information, insights about it. That's where automated BI comes into picture. There could also be a case where I want to categorize all my support tickets. I'll talk about that example as part of my demo. So I want to categorize all my support tickets. Then that is going to be another use case where you want to do this stuff. Okay. Code evaluation, code generation. I want to evaluate code and generate code. That is also one of the natural use cases. We'll not see about evaluation and generation. Probably we'll do generation of a code, maybe for SQL. I want to generate a proper SQL that I need to have so that I can execute against my data. Second one, conversation analytics, right? What we're going to talk about in conversation analytics is that so we want to have customer support assistance being worked out, right? Being helped with these data, right? That is something which you want to do. There's going to be internal chat assistant. We've been seeing these cases in many of those organizations right now, where we always have a virtual assistant comes into you and you click help on the website, right? If something pops up and she keeps asking questions, it's basically the conversational assistant that we are doing. Text processing and summarization. So, for example, document classification, entity extraction, note summarization, document data extraction. These are also text processing and summarization. So these are all comes under text processing and So these are the three different general buckets, I could say, where your top Gen AI use cases comes into picture, because these are the places where the percentage of people who are working with this data or the data behind these use cases are going to be non-technical people. So where these people need some help. So you can develop an app and give it to them so that you can start using it. All right. Great. So we'll talk about each of those things in that thing, right? So we'll talk about Snowflake Copilot and we'll talk about Snowflake Cortex Analyst. I'm going to show them all in demo. I'm not going to get deeper into details like talking more on slides. I'll talk each of those conversational assistance, text processing summarization, fine tuning. So everything on document AI, all these things I'm going to just jump into demo and talk more about when I run through the demo. All right. So let's go here and go to my screen and I'll jump to Analyst first. Okay. So before that, let me go show you something what I have. Okay. Let me start the data. So this is going to be a fictitious use case, right? So imagine that I'm going to help an organization, even within my organization, I'm having somebody going to help with this customer support team, right? The customer support team is having tons and tons of tickets. For example, right here, let me go here. I see a very basic use case before we get further. So right now, if you see on my screen, right? So you see that each of these use cases, for example, I have lots of service support tickets. Let's say, for example, in fact, like it should be 150 or something. So, and each of them belongs to different service type, which means that there are different services that where this support ticket has been raised. And these are varies from various text, languages, and other stuff. In fact, it all is in English right now. But the text could be varied format, it could be short, long, etc. And the contact preference is also going to be on different things, the text message, Gmail, or somebody calls you and asks you and all these stuff. So what the very fundamental use case I'm going to talk about, again, I'm going to apply the same thing with Cortex Analyst as well, is that, so this one, what basically happens is that I want to categorize all these tickets. So in production, literally, it's going to be millions and zillions of data, right? So what I'm going to very first going to say, okay, I'm going to do it using LLM. So very fundamental thing that I have to do with LLM is that I have to give it some guidance, right? Saying, hey, how I can do this whole stuff. That is where the whole categorization comes into picture, saying, okay, I have to define a prompt, and then I use all the categories that my business has defined for me and give it as a prompt. Prompt is basically guidance that I give it to LLM, saying, okay, hey, extract this information based on what I say here. For example, let's go through each line of this prompt, right? You are an agent that helps organizations that come to our support team. Okay, I'm kind of an agent who's going to help them, right? Request category is what I need to categorize because usually that's where the biggest problem starts because in an organization, we write complex business rules, what we call as BRLs and all these stuff, DR decision-making rules and all this stuff, and then kind of make sure when you categorize the whole data, then that's going to be something like which is going to take a lot of time. And if I'm going to introduce a new service type, then I have to go back to my rules and then update my rules, right? The data is going to be more, it's not able to understand something. Again, I have to write complex business logic to kind of do this. This again, in a fact, these are all natural language queries, right? What is categories? What are the other things that you can do? So I'm just defining all the categories that this particular stuff needs. A roaming fee, slow data speed, lost phone, add new line, closing account. These are the what I call like 5 or 6 categories that my business team knows that the support tickets are going to come for. Okay. And this is going to return only category. I'm just instructing very firmly that try doing this and then return me only the categories. I don't want any other information from this. So one thing with LLM is that you have to be very precise and accurate on what you're asking because it's in the end of the day, it's a machine and then something which is run behind what it's trained for. So we need to be very clear, and this is where prompt comes into bigger importance, and that separate thing is an art, I should say, where we call it prompt engineering. All right. So let's define this prompt, and then what I'm going to do right now, I'm going to use Snowflake's Cortex Complete. This is the first function. I'll talk a little bit more about this LLM function in a second. So this is the very first function that I'm using. I'm going to select the ticket ID. Let me kind of pull up this for a second.
Kamesh,
okay.
Sorry to interrupt you, but
Yeah?
would you mind zooming in your screen so we can see clearly?
Sorry? Oh, you want to make the screens bigger? Is it okay now? This is fine? Okay. I can do that, but let me see. Okay. Is it okay? Okay. So because if I make it too big, right, then it blows out of my screen. So, all right. So the first thing I'm just running it again, just to summarize. So I got a bunch of support tickets, which was coming from across multiple different service lines and then multiple different contact preferences. Okay. So that's what I'm doing. If we have this contact preferences here, so this is where the whole stuff is, right? My first task I'm doing is that I'm using LLM to kind of categorize them. Okay. I'm just going to use categories automatically. I'm not going to use any kind of business logic or what you call as business rules engine, what you usually called as to kind of go do this stuff for me. It's going to be natural language using LLM. Okay. So these are the 5 categories that my business has given to me. So I'm just going to categorize all these support tickets under these 5 categories. So as I said, prompt is the very first thing that you have to give to LLM. Then what I do here, I'm kind of building a simple SQL, select ticket ID and request, which is a natural, the normal thing. And this is where the first LLM function that you're seeing, kind of Snowflake Cortex.complete. The complete basically uses your prompt to kind of go query the LLM and get the data back. Okay, we'll see more about other functions that is available in a second, maybe like a couple of minutes where we talk about more about LLM functions and what other things are available. And then from support tickets. So if you're using ChatGPT, if you're using Claude, or if you're using any kind of other enterprise AI things, right? I mean, they basically don't touch your data, right? They all work under the generic stuff that we already have been trained for a particular time, date and time and thing where they can know the information. Right now, if you see here, this is the power that Snowflake is bringing in where we're telling you that you can go work on your data with this particular LLM query. So I just have a prompt created, it's the prompt that I created. I'm doing a simple concat of prompt plus request. Request is nothing but this is the request column, right, that I have on my table. And I'm getting a ticket ID request and this response, right? What is the category is going to be? I'm just going to get that stuff. Let's click on this. So all these functions are available in Snowpark. If you heard about Snowpark, this is our whole Python library. So we got the response in less than 5 seconds. It categorizes all my tickets from the request and then say, okay, it's coming under roaming fees. This is coming under closing account. This is coming under adding new line. This is coming under slow data feed. So everything done in a snap of finger, right? Because I don't need to wait. Tomorrow, if I'm introducing a new category or service type, then all I have to do is to go back to my prompt and adjust my prompt to include this one. That's all. And then rerun the query. I'm going to get the response back. Great. So this is what I call as the easy side of our guiding principle, right? Because in fraction of seconds, I was able to do all this stuff. All right. But the real interesting stuff right now, what happens is that I'm just going to touch upon a couple of new things here. So one, large LLM response, if you remember, like these are the big models, which means that in the production, right? And basically, I'll be running this whole stuff against millions and billions of rows. The large models are always expensive. So they are not suited for this particular generic purpose, right? Where in my case, I'm going to categorize stuff. So these are not used for this particular categorization of stuff. So what should I do then? So don't worry. So we can try to see if I can able to take a smaller model. For example, Mistral 70. If you see here, I was using Llama 3.1405B. This is the best open source LLM model available as of today. So that is what I'm using here. So which is very expensive, and this is not used for this particular thing, right? So what we will do now is kind of go and see how we can fine tune this stuff. I'm just going to pause this here because I'm just going to go back to Analyst and then see what we can do with this. Okay. So because fine tuning, I'm going to talk a little bit more about fine tuning, why fine tuning, and then I'll come back to this again. Okay. Let's go back to Analyst. So because that's where we are staying here, right? So what Analyst can do. So let's say I have a query, right? So I'm an analyst, I'm a business user. I don't know anything about SQL, or I don't know anything about Python, or I don't know anything about any programming language that I use. But what I want to know is that there is something running. You see our support ticket data. There is something running in our support. And I want to find a way to understand what all the causes of this, like how it can be distributed, derive more insights into it. But I'm just going to use plain English. For example, I want to break down all my support tickets of service type, cellular versus business internet. If you remember, like these are the two things that we had earlier, right? Where was that? Okay, so just let me go here. Let me go to the worksheets. Yeah, let me go here. Okay. So these are all the things we have, right? So we have the service type here. So this is a large response model. Let's go back to the data here. So this data I have, this data is cellular and business internet and other type, right? So what I'm basically doing, I want to categorize, I want to get insights. How many support tickets have come in cellular? How many support tickets have come in this? So I'm just using natural language here. I'm just going to give a query to my data. What right now happening is that it's kind of doing what I call as a Cortex analyst. Okay, so Cortex analyst, let me go do this one. Let me do an edit as well. Okay, just give me a second. The whole thing is starting right now. Okay, so what we do with Cortex analyst is that we go against a database, obviously data and models, and then there is a semantic model that I'm going to give for it. So what is basically a semantic model? Let me see if I can get your data of the semantic model. Okay, it's not here. So let me copy it from my. I'll show you what it looks like. It's just an YAML file. Let's see. Okay, support semantic model. Okay. I'm just going to open this here. So I'll just load this a little bit bigger. So don't worry about what is there in the data. So I'm just going to say, okay, I'm going to go to support tickets table, which is a base table in the database and all other stuff. And then I'm kind of giving its dimensions, right? Where it want to go and search the data. I just give a semantic meaning of each of these things. What are the synonyms that can be used? It's kind of to make the data query even more English. So right now I have to handcraft this, but sooner or later, we should definitely be having something which should be done using no code solution. We'll talk about that in a second. So let's say I come back my question. So my warehouse was not started earlier, so that I need to start it again. I give the semantic model and I have the REST API here. So this API is what I'm doing right now using Snowflake API request and calling this message here. The analyst, Cortex analyst class message. This is the path that I'm going to call. So this is going to go query the data in natural language. And it's kind of go getting me the details that, okay, I'm kind of going doing this stuff, get me all the data that is required here. Okay, let's give a few seconds for this to do. Right now, if you see this one here, so can you show me this is my query to this? So this got me the data right here saying, okay, I have business internet cellular, which is like 35 tickets and 114 tickets. And then right now, it also gave you the bar chart that is used for you to kind of pull this data up. And a matter of fact, it also generated you the right SQL query that is going to be used behind the scenes for it to do again. So this against your semantic model. It kind of goes searches the data in natural language, right? So this is making things so easy, right? With Cortex analyst, like if I'm a business user, I don't need to know anything other than English. For example, let's go another question. So I want to go find out all the service type of the customers who are having email as a contact reference. Okay, if you remember the data support tickets data we saw earlier, we had email there. Okay, I'm just going to do that stuff again. So this is going to call the stuff and then come back and then say, okay, these are the ones who have emails as their stuff, right? That is where. So you got 58 unique customers, and then you can also see the SQL query again. So with support ticket, select start count, blah, blah, blah. And then where is your contact preferences, email and service type, etc. So this is the power of Cortex Analyst, which means that it can search, get data insights in natural language. I don't need to write any SQL query. Obviously, you can go a little step further, take the SQL query, give it to your development team or application team, kind of go and do this query. Can you do optimization? Build me beautiful data insights and etc. etc. And this one, I'm using Streamlit here. So Streamlit is used everywhere. You will see all these kind of things that you see on my user interface is all done using Streamlit. And the query is done right within your Snow site. I'm not going out. All this data are sitting just beside, all these queries are sitting just beside your Snowflake data, which means that it's faster and quicker, right? Great. So let's go back here and see a few more things, right? So I'm just going to start this again. So we saw about how Cortex Analyst kind of able to get the structured data, query on a semantic data model, and then you don't have a data model. I think we can go a little bit more, but we have a limited time today. How do we write the semantic model, all of this stuff? But just imagine that I need to give it a semantic model. Once you have semantic model, you can use Cortex Analyst APIs to kind of go query the data, right? Again, it's going to use LLM behind the scenes to kind of do the stuff for you, right? And this is the thing why you have to use Cortex Analyst is because, so as I told earlier, right, the whole Snowflake AI has lots of models run behind the scenes, okay? So what Snowflake basically does is like it goes queries, generates queries in multiple different models and take them all and do the combination of it behind the scenes and give you the right SQL, which is most accurate. For example, if you compare the accuracy of the generation with GPT-4o, other solutions, the Cortex Analyst solution is kind of 90% accurate because it uses multiple models, take the data out, do some ranking, do some scoring, and find out the right SQL that needs to be generated for you. So that's where the test SQL generation happens so accurate that I'm proud to say that we are the leading ones in doing this. Like 90% accuracy is amazing. Okay. So because again we have to combine data, we have to combine other stuff. You can see all these points that I mentioned here. So that's where the whole Cortex Analyst stands. Okay. Now you'll be wondering, what is Snowflake Copilot? Okay. So let me give you an example of Copilot. Let's go here. I'm going to go to let me spin up a new worksheet. Okay. I'll just use a database, use role. So these are the standard ones I'm going to do. Use role. Definitely is going to use my role, obviously. And use database. I have my database. So I'll just use this. Okay. I have to give the context, set it right, and then use warehouse. Okay. Do all these things right now. Right now, imagine that I'm inside this database. Okay. And then if you go to databases, and if I go to my LLM demo stuff, I'm just going to pin this. I have a data thing, and then I have a schema. I have a bunch of table where the support tickets and everything is there. Okay. So let me do one thing. So let me first write the query that we usually do, right? So let's see, I have a call transcript table. Let me go select call transcripts. Okay, I need to use a schema data. And then what I'm going to do right now, I'm just going to use select start, from call transcript table. I'll just limit to, let's say 5 rows, okay, 10 rows, just for demonstration purpose. Okay, it's running mistake. So now what happens? Let's say I have this language, country, French, German, everything, right? So what I can right now do is like, I go to Copilot. It's again driven by LLM functions behind the scenes. Automatically your context of data is sent. Let's say, can I get all transcripts? I'm going to do this in a natural language, which are in German or French, okay? This is what I'm going to ask this. So this is what is going to go behind and do exactly like what Cortex Analyst did. This is going to go behind and then it's going to generate your query saying, okay, select star from blah, 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 call transcripts where the language is French. So when I go hit run, I can just hit run right here, and then you should see all the transcripts that has in French. Okay, this is what the power of Copilot is, right? So you'll be wondering, okay, what is Copilot? What is Analyst? So these are both of them are doing same stuff, right? That is the thing that will be running behind your scenes, right? Let's go find the difference what they are. So these are all similar ones driven by similar LM functions behind the scenes, but they have varied usage. Okay, let's go and find out what they are. Okay, let me go back to my screen. So these are the differences, right? So this is more like Copilot is more for somebody who is technical, okay, who wants to do some stuff right within this. So he knows about how to write SQL, you understand SQL, you understand Python, you understand other stuff. And then it's kind of like that's what we do, the use case and end users. It is more used within Snowside because to give you the same feeling that you're doing with Cortex Analyst outside, okay, can help user write SQL queries based on the data. That's what we're going to do. That's what we saw, like we generated transcripts only in French. Context, again, using universal search, and then precision is very high, right? Like kind of high, like mean to say, okay, it gives you some more close, right? Cortex Analyst is on the other side, as a name itself suggests, it's more for business and other analysts to kind of go work with your data to derive insights, conversational self-service analytics apps for business users. That's what the use case of Cortex Analyst is all about. Okay. Users, business users, more natural language. It's going to use REST API. You don't need to be inside, no side. Direct answers to business questions. Okay, it's going to be more language centric, and then it's going to be tabular, graph, and other stuff. Obviously, I have to give semantic model, which needs to be. But if you saw the graph earlier, this is kind of super high precision, right? That's what Cortex Analyst was able to do. Okay. Again, it was also able to generate a SQL query also in addition to all of this stuff. So this is the difference between Copilot and Analyst, right? So again, if you have to think in a shorter way, think Copilot is all for developers. Okay. And Analyst is all for business users. That's how we think. And then that's how we separate these two things against. Okay. Great. So we talked about Cortex Analyst, and then I just started about something called a hybrid search, another thing, right? So this is where the conversational assistant comes into picture. You'll be wondering, hey, how do somebody is waiting on phone, asking me for questions. I want to answer those questions to those people. And obviously, when you're listening to those little nice IVR music on your screen, right, you get irritated, right? Because the same thing happens to the customer as well. And the data would have been buried in tons and tons of documents, PDFs, internal knowledge portals, etc. So I have to go do the search and get the data out. Okay, that's where the conversation assistance comes into picture. Where we use a technique called as RAG. I'll explain what RAG is, right? Basically, you can go to do information lookup, ask questions. For example, these are some examples which I gave here. So we'll be seeing an example where I'll be going and asking a question about a particular customer's query on an invoice. Okay, we'll see that in a second. But let's understand what is the principle or a technique that drives behind this. So the technique that drives behind this is called as RAG, retrieval augmented generation. If you remember when I kind of introduced LLMs to you, I said LLMs basically what they are doing is that so they are trained on a particular day and time. Okay, which means that on more general things. So they don't have a context. If you want to query a data, your support team want to query a data based on your internal stuff. Mean to say, okay, I am a support tickets. I'm a telco organization, for example. I want my support tickets to be there. My domain will be more local support, right? I want to have about telecommunication, roaming fees, or internet, or something else which is related to my business. What in the short we call them as domain, right? The domain information is not available for LLMs out of the box. So with this technique, what we basically do is like we take all the documents, we inject domain into this particular LLM, and then make LLM answer the questions based on the domain. For example, let's say if you want to answer questions on invoices of a particular customer, then what I basically need to do, I take a generic LLM, then I take all the invoices, it could be PDFs or documents, another system which is giving me data, and convert them into what is called as vectors, extract and chunk. That is what the stake. If you just follow this thing, right? When I do a build, I ingest the data into the stage or a table. It could be documents or it could be other data, scrape the data from other knowledge bases or internal systems, etc. Extract and chunk. What I mean by this is that I convert this whole data into what is called as vectors. Okay? Vectors, like if you go, it's canary of floating point numbers. Basically, I put all the data into this thing, and then I do index it and store it inside a table. And so usually what happens, people will be using, when they're using RAG technique, they'll go back and say, hey, I want a vector database. No need to worry because Snowside is already a data expert. So you don't need to go for a separate vector database. there is a new column called as vector column that is already introduced by Snowflake, where you can store this entire array. This whole array is a floating point numbers. Okay. Now what happens whenever the chat asks a question, the question again will be converted into vector, and there will be a vector search that will be done using Cortex search, which means that there's going to be a semantic search that happens on top of your data, on the chunks, using the questions, and all the relevant documents will be retrieved, and those relevant documents will be set as part of a prompt. If you remember the prompt, there was a request which you sent earlier. So now what we do, basically take all these data, put them inside the chunk, and then send the request back to LLM. Now LLM has the whole context of what data and what top of what question context I need to answer the questions on. And then it gives you the answer more relevant to your domain. Okay, I'm just going to repeat the whole stuff again. When you build, take the data, take the documents. For example, let's assume it's PDF documents. Take all PDF documents, extract the data from them, and then chunk it. Chunky means convert them into vectors and store it inside your Snowflake table, right? And then extract all this data. Whenever the question comes, I'm going to do what you call a semantic search. It's going to go search the vectors. It's going to compare the numbers. The similar, what do you mean by semantic search? The similar floating point array number vectors are going to be in similar space. I'm going a little technical. I'll just stop here because I don't want to go super technical there. And then I'll imagine that's a space where I go search the data. Okay. And then I'm going to take this data, search it again, and then get back the data for you. And then now I have the whole context, relevant documents, because I have the chunks, similar documents will be there. And I'll take these documents and give it to the prompt context, right? And then now, when the query runs against, the prompt runs, guidance runs against this, the Snowflake LLM, I mean, not Snowflake LLM, sorry, the LLM in general will go on query based on the prompt. If you remember, that's a guidance that I'm giving to LLM. Since LLM is having the context of all my documents, it's going to query and search the documents and get the data for me, which means that it's easy for me to go and search my data. Okay. So let's go see how this works, right? So you'll be wondering where I'm injecting this one. If you remember, let's go back to the fine-tuning example which we did earlier, right? When I was doing, if I was doing this complete function, right? What I was doing is that I was taking this prompt. There was no request data here. But what I did kind of did a concatenation of my request that I took from my data along with the prompt. This is exactly same thing we'll be doing, but all this thing will be done behind the scenes for you. You don't need to manually take and merge it together in the prompt. Okay. Let's go and see a demo of that. So that's what the whole stuff is done, right? And if you're wondering what Cortex search is like, let me go see which thing I was in. Just talking about Analyst, talking about search. And what we are also, I just want to talk about this and just jump to the demo. I think we are at okay, we got 15 minutes if I'm not wrong. I should be completing by 15 minutes. Okay, so what we did, we saw all stuff here, right? So what in Snowflake we did, we also went a little step ahead, and what we did was called as hybrid search. So what we mean by hybrid search is that I talked about semantic search right now using RAG. We also do a keyword search also on the data, and then take both the things together. That's what you say, semantic lookup and keyword lexical lookup. Get all the relevant documents or results and then reorder them or rank them and then use them. So in which ways, like your accuracy increases even further than just normal RAG. Okay, so let's see how this works, right? So let's go back to this. Let's go back to my demo, Cortex search. So these are the documents that I opened it up. Let me go and open a document for you. Let me go to Snowworks. And then let me go to my demos. I'll open one document for you so that I can GenAI and then LLM demo and data. So this is one document that I'm going to query. So if you imagine this is a normal PDF document. So what I did basically in this PDF document is that I'm going to query this customer is on phone, for example, named Gregory Anderson. He's on phone. He's asking me that there was something charged for him on his credit card for last invoice. Let's say he wants to understand why he was charged. Okay. And your customer support has been waiting on the thing. So I cannot go into open tons of documents and open all these stuff. So what I basically did, I kind of uploaded all the invoices through some kind of an ingestion mechanism into my table and converted them into vectors. So my first question before to answer the customer is that before even I know why you was charged the fees and the customer is on phone, this is kind of a chatbot that your assistants or your customer support people can use. I'm going to say what kind of service that Gregory has. So this is the very first question I'm going to ask because I don't know what thing that Gregory has. Okay. Now this is going to be, again, this has to start the thing. Okay, give me a second. I'm starting the whole stuff here. So I showed you this document so that like I can relate the context for you. But and I assume that your your customer support guy doesn't know where this old document is all about, which document is all there. Okay. So these are the documents I have. So this is going to be in this document. Let's see where it comes from. I'm just going to give a query saying, hey, what does plan that Gregory has? Okay. Now it's going to query the document. It says Gregory has cellular service 2 line plan. If you go back to the document, it's here, right? And then now I'm going to ask him whether he was charged a roaming fee, right? Let's say I'll ask him, okay, was he charged a roaming fee? Yes, it's going to say, yes, he was charged a roaming fee of $85, blah, 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 because this was something. And then customer support can suggest, okay, you can go buy a new pack every month if you're going to do an interest roaming fee. In fact, I can also go and ask this. Let's try and asking this. Can you tell me which invoice it is? Okay, just for us to say, okay, if you want to go find out if there is an invoice, okay, this says the invoice number is 9987. I can go back. So this is what this is, right? 9987 is your invoice number. And then I can go back to my system, start querying my data and find out more details to help him in case I have to do it. But this is where RAG comes into picture, right? I'm kind of merging the documents using against the LLM. And again, this is a Streamlit app. You don't need to do anything extra. All these chat interfaces are available out of the box in Streamlit. You can just need to connect your data and your LLM calls. That's it, right? And then it does a Cortex search behind the scenes to go and kind of take the data out and then give information about it. Okay. So in this case, your customer support team can become more efficient, right? Because I can query the data fraction and handle more customers in peace because I have all the information that I need to support them. Okay. Great. So we saw a couple of other things. Let's go further and see what else we have. We saw Cortex search, text processing and summarization. I'm going to give you a couple of examples of that. We can do a lot of other stuff. And then you'll also see about how do we do, right? How the call is being done, what we can do. For example, all these things we're using. You saw one example of Cortex Complete earlier, okay? And then these are the LLM functions that is available. If you go to docs.snowflake.com, search for LLM functions, you'll see all the LLM functions. You'll see examples of each of these in a second. And then, as I said, these are the foundation models we have. These are the list of models that we have. You don't need to worry about what models, just use the model name. Don't worry about how to load them, what infrastructure is needed for you, how do I do other stuff. Everything is taken, what RBAC, what ACLs, all these stuff are done by Snowflake. All you have to use is just use them. And then obviously it's paid for service, right? So you pay for the service, that's all, okay? But these foundation models act as a very core stuff for all the things that we discussed so far and all the things that we are also going to discuss, right? These drive the apps. These foundation apps drive the apps that we are going to build using these models. So again, this is just an information like what we are going to use, Cortex ALLI, Snowflake Container Services. I'm not going to touch Snowflake Container Services now because it's most advanced use cases. For now, we just concentrate about like what all things we can do with these foundation models. Okay, let's go quickly see the LLM functions as well, right? So let me start this one as well. I'm going to give you an analysis of a few things that we already have and then kind of go with all those things, right? So I'm going to import some packages. I'm using Snowflake Notebooks. Snowflake Notebooks gives you power of executing Python and SQL in the same stuff. And I can also take the data from SQL cells into Python cells, use Streamlit right within the notebook. So all these things comes as a great power for a developer to kind of develop some stuff. Okay, it could be LLM or it could be any other SQL thing that you're doing with Snowflake. Okay. So, for example, we know that we are dealing with this particular support tickets thing. We already have the classification of text, right? So, what if basically this function will do? This is again a low-code function, which means that all the logic, business logic regarding query, prompting, everything is hidden behind the scenes for you because Snowflake just gave you the functions out of the box. You can just use the functions like what I'm going to show you right now. For example, I have all these support tickets. And I want to classify these support tickets into 2 categories because I'm just dealing with 2 service types right now. One is going to be internet, another one is going to be phone. So what I'm going to do is like I'm going to take the request as text, and then I'm going to give this text to this classified text SQL function, and then give it an array of classes, and then classify them based on what array of classes I'm going to have. For example, this is what the owl output you see. I'm just going to run this query. So this is going to run this query, and what it's going to do right now is going to take the text that is there right here and then analyze the text and then going to find out which categories this belongs to. Okay. So let's give few seconds for this to run. So right now we got the response back. I traveled to Japan. Let's take this one. I traveled to Japan for 2 weeks, kept my data usage to minimum, etc., etc. So now, naturally, when I gave it an internet or phone, obviously the classification comes as phone because I know this is going to be a phone request. Okay. And then again, there's a customer. This is here what it talks about. Okay, I'm satisfied with the service. No longer I need it. Blah blah blah. Then what I'm going to do is like I'm just kind of going to classify them as internet. I think this is just a very simple example. But if you can imagine a real user scenario, right, where I want to go classify text, where again semantic search and Cortex search is done behind the scenes, is going to search the data using semantic search and keyword hybrid search and find out what is the nearest closest class in these two things that I can associate with that. And everything comes with this code. Okay. For example, if I don't take label out, right, I'm just going to give this one. You'll see a JSON response right now, which means that the JSON response as a score. So all the API calls, the LLM API calls, LLM functions call that I show you right now, everything gives you a score back. Meaning to say, like if you're developing an application, you can go find out. I think this one has not got the score yet, but you can go find out the score as well for them. And then I'll show you some example down below. So analyze the score, find out which score is high, because it's all no LLMs can be perfect. So analyze that and find out which is going to be closest for you. Okay. So we saw about complete, and these are the models right now we have for complete. And as I said, they're all classified in this. If you see, go to the docs, you know which are the larger models, to the smaller models, and other stuff. In this case, I'm going to use Snowflake Arctic. And what I'm trying to do right now, I have this question right here. So which says, okay, I traveled to the same request from there, and I want to summarize them as a bullet points. Okay. I'm going to run this query now. So this is going to, I'm just limiting this to one for making it real quicker. And then what I'm going to do is, like as I said earlier, the power of Snowflake Notebook is that there is a cell called as complete. And then I'm just going to say 2DF, converting to a data frame, and then 2 pandas, which means that the whole data can be right now got as pandas. Okay. So this is the power of Snowflake Notebook, because I can take the cell, reference data within cell. Not obviously, you know that I can reference Python variables, but if you're running SQL, I can take the SQL output also, SQL variables also within this particular next subsequent cells. So that is again power of what notebooks brings you to do more stuff, to develop more efficiently. Okay. I'm taking this whole output here and converting this to pandas, and you know this how this works, complete DF and all this stuff, taking issue summary, text, and then plotting it here, right? This is what I'm doing. I'm right now using Streamlit here. That's what I said. I can just use any of the Streamlit with just inside Snowflake Notebook. So this is the text, and this is the bullets of the text. So this is again what summarize can do, right? This is a complete function which is going to say, take a prompt and do this stuff for you, right? The other important thing is whenever you deal with customers or customer support tickets or any other kind of stuff, right? The very important thing you'll do always, you do with sentiment analysis. Okay, what is this customer's tone on this request? What he said, okay? Whether it's happy or whether it's not happy, or whether it's disappointed. So what I did is like I kind of go and run this one for you. This is going to bring me like last 10 support tickets, right? It's going to give me a score between -1 to +1. That's always given by that. I just rounded it off to make it more neater and cleaner. Whenever is like -1, the sentiment score, using this Cortex sentiment function, I'm running it on the request text. It will analyze the text to find out the sentiment. If it is going to be -1, then it is negative. It's going to be 0, it's neutral. It's going to be anything above 0.5, right? It's going to be like happy, right? You see, there is a bunch of things that I have here. It's going to be sentimental. To make things a little bit funnier, what I did is like I kind of took the same data out to DF and the kind of plotted it like your with all these emojis, right? Which is happy, neutral, sad, right? So this guy is like, for example, which are unexpected, not clearly explained, please issue refund, right? This guy is not happy, so I know that my customer is not happy, okay? And this customer is very, very happy. I'm just saying I would like to add a new line because he's adding a new line, which is making me this. And any other things, I'm just plotting it as neutral, right? With these emojis. So you can mix kind of things, go present a more visualized stuff, analyze your sentiments, do what is required for them. Again, the same customer support thing which you're talking about, right? This is great. And then there's also something called a summarize, right? What I can also do is like if there's a huge request, for example, this is going to be these many lines of code. What I can also do is like I can go around summarize, just basically go to run the summary of the whole stuff. Okay. For example, this is like what so many lines of code thing, and this is going to be in like 3 lines of thing. So, and if it's going to be huge text, it's going to summarize that whole text into a smaller one. For example, this is the one which I'm going to use another. Complete, summarize in 200 words. I'm using a prompt. You can also use a prompt as well. If you remember the prompt that we discussed earlier. This is going to put a prompt here. And then again, I can just run a JSON summary. I can say what I want data in the format as. I'm telling that I want it in a JSON format. I got the data in JSON format and then extracted some of the things, right? I say summarize this request less than 200 word, put piece, request, and country in a JSON format. Extracted piece, request, and country in a JSON format. So this is the request. I travel to Japan, blah, 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 and then kind of pull these things out. Okay. So this is prompting. And then I can also do translate. We don't support the plethora of language that we have right now. These are the only supported language. You can also always go to our documentation to get the updated language that we support. For example, I can run the same translation on my table. For example, I'm running this one against Cortex Translate the text from my support tickets. I'm converting that text from English, which is already I know, into French, making it a little bit more readable here. This is a text that was in English, and the translation was done in French. Okay, I can just do French request. We will call the translate function. The data, the text from which language to which language. Okay, these are the only supported languages we have for now. Okay. Great. So I can also do something. For example, on the same request, right? So this same request, I traveled to Japan for 2 weeks, blah, blah, blah. I was charged $90 fees. So I want to extract some answers out of it. Okay, I want to know what is the fees that is charged. Okay, I'm saying extract answer on the same request. How much roaming fee was charged? Okay, and then I'm going to get the answer out. This is going to extract. I'm going to read the thing, take the thing out wherever the fees is applicable, and then kind of gets the data for you. Saying okay, it's charged 90. If you remember, this is what they are charged in this. Okay. And then this can be applied to any other stuff. You give the data and give the answers, and then going to extract answers from the text. Okay, whatever question you are asking for. Again, it's a natural language kind of querying it. Okay, let's get to the more interesting stuff on how to do this documenting stuff. Okay, so let's go back to this thing. We talked about document LM. I'm just going to run the demos because I'm running out of time to kind of talk about all of the stuff. Talked about element. This document AI where I can give a document, extract the document, and build a model around the document. And then I can supply new documents to it. It will be able to extract the code. Okay, that's what the document LI. It uses Arctic tilt. Again, this is the best performing document extractor. Okay, for example, you see it's up the score on this. These are all generic third-party stuff which is done on these benchmarks. It's nothing to do with Snowflake. Snowflake Arctic sits right on top because if you see the Snowflake Arctic, it is 90.2% in performance with just 0.8 billion parameters. Okay, if you see, so Google's model 90.84, but it has 48 into 55 billion. Okay, something as QNL Max 93.6 has 9.6 billion. So this is efficiency, right? The smaller the model, the smaller the cost. And here we have made sure that it's also smaller and it's also efficient. Okay, that's what Tilt does. Okay, let's see this. Let's see an example of Doc AI. So this is where I'm going to introduce to you. If you're on Snowflake, Snow site, you can go to all these little star-like things where we have other stuff. We have a studio. I can run everything from here without writing even a single piece of code. This is what we call as no-code solution. Then I have features here where I'm not talking about features. I think we have one model trained. This is a fine-tuning demo. I'm not sure I have fine-tuning demo to show you this. This is where the document AI stuff is, right? I'm just going to select the warehouse. Going to select my warehouse here. Okay, I already have a document trained, okay, just instead of time. So if you see this document, this again, I trained this invoice document here. So I'm just kind of extracting the information from this invoice. This is what it's going to do. So it extracted the information from invoice and then it's kind of see all the documents that I uploaded. These are the sample documents. Again, in my case, I just have 4 or 5 documents, but the more the documents you give, the more accuracy it has, okay. So what I did from these documents, I extracted invoices, okay. For example, let's say what is the invoice number that I have, what is the PO number I have, what is the due date, what is the customer name, etc., etc. Okay, this is what I'm going to do here, extracted from these documents, like these ones: invoice number, customer name and address, balance due, PO number, due date, and international roaming fee. Okay, these are the ones that I extracted out of this document. Basically, I train the document when I do this. For example, when I click on this one, and let's open this document. If you see here, this is an invoice. So automatically when I ask question, it comes out and tell you what all the questions and answers for them. If you want to correct the answers, you can correct the answers and tell it this is a correct answer, and keep doing that for all the sample documents that you upload. Okay. In this case, I was trained these things in such a way that it was able to extract most of the information without me doing it. So I kind of go and picked it up. So it kind of give you the answers. Once I have trained the document, what I basically do is that I go and kind of publish a new version, which basically creates a version 1 here. Okay. And then it also gives you how do I extract data from the document. I can upload documents into my stage, Snowflake stage, and kind of go run the query against using predict. And this is a version that I give it to it so that it go extract that particular version of it. All right. Let's see an example of that. Let's go to my LLM functions. I have an invoice. If you remember the invoice that we talked about, this guy, Gregory Anderson, the same invoice, I'm having 9987, and I'm not trained this document to do this data. This new one that I'm sending it across. I'm going to pull in prediction. So this is going to take a little bit of time. You kind of go predict and then get the invoice data out. And then it's going to read the PDF and then kind of do the stuff. So you can produce any new PDF. As I said earlier, the more the number of documents you give for it, the more accuracy it will be there. Okay, that's what I'm going to do here. So I saw this one, all these documents right now, the model accuracy stands at 1, which is beautiful because 1 is like the best. Okay, and then it was able to extract the data perfectly on this. Sometimes it will not give you 1, so you have to keep tuning it, keep adjusting the values, keep adjusting the parameters, change the questions, and do all of the stuff. Okay. So let's go back here to see if it's done. Okay, that's done. So it's got this data. I'm just going to let me run this one so that I can show the data in more neat format, right? This is what Gregory Anderson. Again, I'm using Streamlit here to kind of show the data with invoice number, purchase order, customer address and name. If you remember this, 1334 Elm Street, that is what here. PO number is 703458. Cellular service and due date is February 24, 1919. Total bill is $190, of which is $85 is roaming, and just plotting that 44.52% of that particular bill is roaming bill. Okay, that's what is Document AI. And if I have 2 more minutes to go, I'm just going to cover serverless fine tuning. This is again an advanced use case. Probably we'll do a separate session. Probably I'm running out of time for this. So where I can take the larger model, fine tune and give a smaller one. Okay, so let me explain that. If I can take few minutes, I can just run through this as well. So if you remember, we ran all these things, the larger model, like I said, running this against a billions of rows is going to cost you like what? More cost. I want to reduce the cost, but want to do it efficiently. For example, I'm taking a smaller model here and kind of running this against smaller model. Right now, what happens, the smaller model's accuracy is not as accurate as a larger model. For example, this larger model was exactly able to pinpoint and say roaming piece. But this is kind of, okay, I know this is blah, blah, blah. It talks all other extra words and everything. Okay, this is not accurate. So that's where fine tuning comes into picture, where I can basically fine tune the model. I take the larger response example, take the one against smaller model and build a model and then train the model to be more accurate in a specific task. Okay. Don't worry, I don't need to write any code. If you remember with the AI/ML Studio, I can create a fine-tuned model, just click of a button. So you don't need to do anything else. That's how I created this particular model called as support tickets model. Okay. The support ticket right now, I'm using a smaller model for this, but this model is going to do a inference right now. For example, I'm using support tickets fine-tuned model, and then I'm going to run this ticket against. So this is going to give me the same response like the larger model, but the cost right now is going to be 1/10 because I'm running a smaller model, which is a smaller context window. Okay. Now, if you see, the smaller model is able to get this data right here as I wanted it, like exactly what the larger model was doing. So fine tuning is more about what we do is like we take the larger model response and then we kind of bring it down to the smaller model so that I reduce the cost. And also we take the general purpose models. One thing you have to keep in mind is that they are general purpose, as I said, and they are trained for many things to do. In this case, I want to categorize my support tickets, which is my only task. So I can take a smaller model, which will give me lower cost, and take the output from the larger model, which are called as examples, and train the smaller model so that it's able to do one task that you give it to it at one. Instead of doing jack of all trades, it's going to be king of one. Okay? That's what is fine tuning. It's a very advanced concept, but don't apply fine tuning on changing data because you have to keep running the fine tuning process again and again. It's only, so for example, if data is like changing once in a year, once in 6 months, then that's where fine tuning comes into picture. And lastly, I just want to touch upon security and governance, fully secured, right? Whatever the security things that we have on Snowflake is all applicable to GenAI, ML, and everything. No training on your data. So we're not going to train the models on your data. It's available at the customer base. No request to third-party services. Everything, all the calls that we saw right now is everything happening within Snowflake and within your account. No what you call as commingling of data. So we isolate the customer data at software level. So no data is ever mixed with another Snowflake customer, which means that your data is your data. Okay. And then we also do something called a Snowflake guard. We talked about a little bit on this. So protected IP, we can control the IP and other stuff so that the query comes only from these IPs. Fine-grained access control using Horizon, you can do that. Cortex guard is nothing but where I can kind of add another parameter to my complete function called as guardrails, which means that, okay, don't do this stuff for me. Okay. Filter the response for hateful crime or other thing which is not ethical or not good. We can always filter those things. So for example, this is an example of how Snowflake guardrail works. For example, somebody comes and asks a model, "Hey, how do I make a bomb?" I don't want to say how do you make a bomb because some of the models do give you a response for that. So when you put guardrails equal to true, then it means that this response is filtered. Whenever somebody asks, it will not respond saying, "Okay, I'm not supposed to answer. I cannot do it," or some kind of a response it kind of gives you back. Okay, that's what guardrails. I think there's more thing which you can add to the complete function. I don't have a demo for guardrails, but I leave with you a ton of resources for you. I think I'm not sure. I need to check with Shubhangi to see if we can share the slides. And if you're able to do it, I'll share those slides. But the best place for you is to go to docs.snowflake.com and then go find out, just search for LLM, and then you'll see all these things we talked about right now. Okay. I think that's what I ran 3 minutes over. I'm really sorry about that. And back to Lalita and Mansilal.
Yeah, thanks, Kamesh. That was a really informative session, and I think I speak for all of us when I say we are excited to try out all the new LLM functions that you have covered in this session. And
I think the best place for you all to get started is like you can go to quickstart.snowflake.com. I think I'll put these links on the chat if you want, so that you can get all these things. So let me. I'm going to put a Google Doc or link on the shared, Zoom chat. Probably let me stop sharing it and then put it on the chat. I think I request Nalita and Mansilla to kind of share it with the audience. So that document has lots of stuff that you want. The mostly like the stuff that you want to do, etc., etc. So these ones will be able to do the stuff. I think links, documents, all of the stuff that you want to do. So these are all the ones that it has inside that. So please use the document. I have produced the courses, the labs that we actually do, and all of the stuff, right? So we're just putting all these stuff inside this. You can just use the document for that particular purpose. Okay.
Sure. Thanks, Kamesh. Yeah. And we'll make sure to share the presentation and the links.
I'll just quickly share what the document has so that in case somebody wants to know what's the content, it is there, right there. If you go here, you see this document as discourse, the user forum, where you can go ask questions on whatever stuff we have. We have North Star conferences running everywhere. Shubhangi will let you guys know. We have a user group. Obviously, we have one Hyderabad user group, which is there. Correct me if I'm wrong, Shubhangi. And then we have a lot of Coursera courses coming up on various topics around Snowflake and other stuff, which are free content. But if you want to get yourself certified from Coursera, obviously you have to pay for Coursera. And these are the ones, we ran one North Star conference in Hyderabad, where a lot of people got badged with all these things. We'll be running again in next year. So look out for that. There are a bunch of other get started kind of stuff for Snowflake Summit. We have Zero to Snowflake, somebody who are completely new to Snowflake, don't understand these basics of it. You can go take all these little quick starts, what we call as. And then there is LLM workshop, which we just, I think I kind of partially ran the most of the workshop for you, but that's what we can do. And then I have compiled a bunch of official documentation and quick starts that will be useful for you to get started with whatever we discussed so far. Those are available there. So in case if something strikes my mind, I'll drop some more links on that particular document, which you can use. Okay. So this is a read-only document. Obviously, you cannot. I cannot share this one. I think because this is more of a public thing. Okay. All right. So that's the only stuff I think I have to do. I think I'm pass it over back to you guys.
Yeah, thanks, Kamesh. We will open up the floor for any questions you guys might have. I think we are running a little ahead of time, but we still have 10 to 15 minutes to cover your questions. Anyone?
Hey, hi Kamesh. Quick question on LLM. So considering myself as a BI analyst, okay. So if I go with the Cortex analyst pattern, okay. So considering a database which is having huge number of tables, okay, like considering as a support ticket model that we have created, right? So let us say there are hundreds of tables which gives the similar information, like day-to-day developers create a number of tables, right? So in how do
Yeah, I
we?
think I need help from Lalita or Bansalal to repeat the question because it was echoing for me. So can you repeat the question for me?
Yeah, yeah, sure. So considering that I'm a analyst where I'm looking for a information of support activity. Okay.
No, 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 no.
Uh,
I can Lalita or someone who's near to the computer can repeat the question what the person is asking because I cannot because it's kind of echoing from there. I cannot listen hear clearly.
okay, I'll be
Or
there.
can you
Right. Yeah,
Sure, sure. That will be great. Yeah, that will be great. Yeah, thanks.
can I allow me to ask? Hey, hi, Kamesh.
Right.
Yeah, the question is something like,
Good. Okay. Mm-hmm. I think see there is see when if you remember the if I take the Cortex analysis as an example, if you want to do the query, then I actually build a semantic model where I specify the table, where I specify the database, where I specify the schema from where it has to pick the data, and I give the semantic structure of the whole thing. So I think basically there is nothing called as a defined frequency, but always I can when I define that semantic model, my analysis is always going to go to that particular table and query the data. It's not going to go for all the tables and query the data. So that's one thing. If you're going to use just complete, again, as part of the prompt, if you remember the example that I showed you, we always add a column from a table which is passed to the particular thing, where the whole Cortex complete function itself is acts as another SQL function as part of your query. So again, I'm controlling which table I want to go. So which means that you don't need to worry that it will go to all the tables. I can control to which tables it would needs to go. Correct. Correct. And also when you write the prompt, we write the prompt in such a way that it goes only to the specific table, specific column. Yes, I think the usually what the recommended approach is that don't create one semantic model for hundreds of tables together. Okay. So just create it based on use case by use case basis, domain by domain basis. If, for example, I'm just handling only one team is handling only, like, let's say, customer support tickets of roaming fees, just create only thing that is related to roaming fees or some other customer type or something else which you have the classification for. Creating a huge model is going to be a headache for you because you have to maintain that. But obviously, when you add new tables or create new tables or bring in new data, if the existing semantic model is not sufficient to kind of query the data, definitely I have to go back and create or update that one. And I think mostly down the lane, like what I showed, the no code stuff, which can be done with mouse clicks. Mostly down the lane, if all, I think I don't have the roadmap or anything within, but it's just an assumption again from my side that we might have similar one for even creating the semantic model so that you don't need to handcraft them. You can just use the UI to kind of go create the whole stuff. Welcome.
Yes, hi Kamesh. So we have a second question from Mr. Santosh. So his question is, if he's uploading a written text versus, I think in document AI we covered invoices, right? What is
Right.
the accuracy of the system giving the results if the text is written?
See, the accuracy is what when you build the model. I did not show you how do you actually build the model because it's a little bit time consuming. Time consuming in sense it takes few minutes for the model to be created. Whenever we upload sample documents, by default it extracts and shows you the stuff. Let me share my screen and tell you what I mean by that. So when I go for my Snow site document AI, so when I go to my model here, and then kind of go and let it load it. Give me a second for this to be loaded. So whenever I see this document, right, when I click on this invoice, so the first time when I upload it, so it doesn't have any questions, it doesn't have any values. So these are all something which I created. For example, invoice number, uh, PO number, due date, etc., it's all created by me. Okay. So what I do in case if I want to add a value, let's say I want to extract state taxes. I just say state taxes. What is the I just give my own question. And then once I do this and then ask the question here, so it will generate you an answer going through this particular document. Okay. But it is up to you to determine whether you want to go with that particular accuracy. You see this
Okay.
1 1 1 here, which means this is the accuracy that I defined that this model is right now. By default, it goes back and pulls this out like say 3.56. It was pretty much accurate, but it says that my score for accuracy is 0.86. So now if I feel this one is good, this is pretty accurate, then when I say click validate the answer, the accuracy becomes 1. So you decide which is accurate. So because because it extracts information, sometimes it might be wrong. Sometimes it cannot be even, it cannot take out the data as well. So it's up to you to kind of go validate your question against the answer on your document
Okay.
and make sure that tag whatever the accuracy you want it to do.
Okay, let me clarify one more thing. I think the question was more as to the capability of the platform to read the data in the file if it is written, handwritten, sorry.
I think again, you are echoing a lot, Lalita. Can you just speak it out, please? I think it does. It does read it. Yeah. Not accuracy. I'm not sure about the accuracy factor of it. Again, it depends upon how much we write, how much we kind of do this. But there are some cases of handwritten documents can also be done. Yes, it can be done. Okay, I think I remember to have showed you the accuracy thing. So because more than accuracy, we talk about more efficiency. Let me go to that slide where we talked about tilt. Let me go here, document AI. Okay, so this is a slide which I talked to you about. If you see here, so this is more of what you call as an LLM again. So I'm not sure. I've not worked on those document extractors, but here it's Snowflake. It's more like we have the tilt model, which is very very accurate and trained on smaller number of things. So which means that the efficiency is more. The second one is that it's as I was saying from start till the end, you're doing everything close to your data and within the data in a more secure way. I'm not sure how the other document extractors behave, but these are all done within your same Snowflake account within the data, close to the data, which means it's become more efficient. I don't have the information about other ones. Probably I can check and let you know.
We have another question from,
Sure.
so the question was, I think in a usual Snowflake database, when we run queries, it caches the queries and gives us results, right? Will
Right,
that be
right.
the same case in case of LLM models as well, or is there any
Yes.
improvement on that?
It all the standard things, all the standard query stuff gets executed. There is no change to that. I think let me see if I can bring out the Snow site and go to monitoring query history. Let me see if I can. I think it says execute notebook. I think since we are running from the notebook, I think I don't have. Let me run a normal query. I think it should definitely cache. Let me go and find out if I have something like this. I think it follows the same stuff. I don't think so. There is anything changed on that. It should definitely get cached. I think it get cached on this query. Obviously, let's see the query profile. It's again, it's got getting from cache. Let's see if I can run one query right away. Okay, let's take this one. I can go to my notebook and pick out one query and come here. Okay. Let's see if I can. 100% should be, but let's double check it once. Okay. Let's check this one. Support tickets. This site. We want to set the situation prompt. And put on this one. To get the response back, I think this gives me the query. Let's run this one more again. Let's see how long it took. It took 1.4 seconds. Let's go here to my query. I think it's from the result cache. Yes, there you go. Okay, so again, it goes from the result cache. I think right now, let's refresh this one. I don't have that query yet from here. Okay, so I think maybe my role doesn't allow me to look other stuff probably. That's because of that. So yeah, I think the query, the response, but there will be you will not be finding so fast because there is some amount of processing that needs to be done by this model. There will be slight extra thing that will be added depending upon the model, but the overall query, definitely the results are cached, 100%. You saw that on the query profile also, like it did not go, it took out from the result cache.
So I think the answer was that even in LLMs, we are going to cache the query, and then the performance will be the same. Okay, thanks, Kamesh. I think we have time for one last question. The question was on document reading, right? What is the limit on tokens? For example, if we have like a big novel like Harry Potter or something else, like what is the limit of the tokens and how do we handle it going over limit?
Okay, I don't remember the limit of the token on top of my mind, but I think the size of the document is 50 MB is what the max is. But let me go and see if I can find the information here. Okay, so let me go this interface. Let me go try to see if I can spin up a new build, though it will not complete on time. So I think there's somewhere I saw the limit. Probably that should be there in our document. I think if you go to the document AI thing, this has an information on the limit. The size I definitely know 50 MB is the maximum size, but token size I have to check. I think I have to check in the document. I don't remember top of my mind. So if you can check the documentation, go to docs.snowflake.ai and then do this stuff, then you'll be able to do that. Yeah. Sorry, I don't remember that context window size at top of mind. I remember to have seen that somewhere, but I don't remember right now.
I think any suggestions on how to handle that limit when it comes to functions like summarize or complete?
Okay. The question was on the context window size of the models, LLM models, you mean? Or you're asking for document A. Okay, the LLM models, I think let me go and show that in the document itself. I think I know where it is. Docs.snowflake.com. Just search for context window. Go here. These are the functions that we have here. I'm just going through the official documentation so that you see the context window size is given here. So usually the usual recommendation, so this gives you the context size, what it can handle for each of this. So if you go beyond this, definitely these are not hard limits. You can go alter as an account admin. You can go change the limits as well for these context window. If you increase the number of tokens, obviously your cost is also going to increase because you will be charged per million tokens, dollar per million tokens. That's a usual charge pattern. So the recommended approach is that don't get too much of context inside prompt. The better thing is always try to make the prompt as crisp as possible. For example, make a prompt give it to summarize or something else, or shorten the prompt so that the number of tokens that is passed to the context is very precise. Okay. And if that is something which is you're giving too much documents, it means that your prompt is not rightly done. You have to go back and revisit how to do the prompt. So naturally, by default, what will happen if you are exceeding the context, Snowflake will reject the request saying, okay, I cannot process so many number of tokens. It will reject the request. It will not even process the request.
Thanks, Kamesh. I think we'll close the session for now. Thank you for joining, and we look forward to hosting you in person sometime soon.
Yeah.
Thank you.
Thank you so much. Thanks, everyone. And have a great weekend. Bye now.
Right. Thanks, everyone, for joining. I think we had a few more members joining while the session was going on. It's fantastic to see so many passionate professionals and data enthusiasts here on a Saturday morning. So after this, we'll have two more sessions deep diving into Snowflake capabilities and Open GenAI. So before that, we'll take a short break for high tea. And the next two session speakers will be here in person. So I would highly encourage all of you to take the opportunity and meet them in person and do some questions or clear your doubts if you have any. Thank you. I think our cafeteria is over there in the leftmost corner. We'll break for high tea right now, and then we'll meet back here around in 15 to 20 minutes. So we'll start our next session around 11:30. Thank you, guys. Restrooms are available on this side of the building, so if you want, you can use the main door to go there. Okay, we'll get started. Thank you everyone once again, and building from the past session, over the next couple of sessions, we'll delve deep into Snowflake's data and AI strategies. Our next speaker is our Chief Innovation Officer, Mr. Samir Bhatt. He has over 20 years of experience in the industry. As our Chief Innovation Officer, he has been playing a crucial role in building strategy and also are maintaining our internal products. So handing over to Mr. Samir.
Yeah. Thanks, Lalita. Thank you everyone for coming on this beautiful Saturday morning, and hope you had enjoyed Kamesh's session on Snowflake's Snowflake Cortex, the LLM features of Snowflake and so on, right. We have covered a lot of features of Snowflake. So I'll start with my introduction. I think Lalita just talked about it, just talk few things about me. So I have more than 20 years of IT industry experience. Currently, playing Chief Innovation Officer role, heading innovation at Anblicks. I've been I'm an entrepreneur. I started my company in 2014, and in 2020, so my company name was Nova Technologies. We are focused on portal, mobile apps and cloud technologies. We merged with Anblicks in 2020, and then I took up this innovation role at Anblicks. So part of my role in Anblicks, we focus on building products and solutions around our services. So Anblicks is a data and AI services company. So we build products and solutions and add value to more our clients. I also authored couple of books in my career, like as I mentioned, like work extensively on one of the very popular open source portal called Liferay. So I authored couple of books on Liferay. They are here, and is my QR code in case you want to connect with me on LinkedIn. You can scan and we can connect. So today I think Kamesh has covered all the Snowflake LLM features and all. My focus of this session is on the application of those some of those features, right. So we have built GenAI powered applications. One of them is we named it Versal Q, which is call center analytics solutions. So I'm going to showcase like what is the use case and how we implemented, what is the architecture and so on. And if there is some time, if we have some more time, I'll cover another solution which is document analytics solution as well. Both of these we are using all Snowflake Cortex LLM, Snowflake Snowpark container service and all those features, right. I am going to cover that part. So before I talk about the specific solution, right. So why we build this use case, right. So I mean call center analytics, like everyone I think must have in their lifespan have called some call center agents for solving their problems if they purchase some product or services, right. And for a companies, right, it is very important to make sure that that conversation, that the quality of that conversation is maintained, so that because it's a way to connect with customer, and it's a way to make loyal customers of particular brand or products or services, right. So it's very important channel for building relationship with customer. And now with in the market, like there are many new things coming up, like new ways, new channels are coming up, like social media and chatbots and so on, right. So there are various channels for connecting, providing support to customers, but still phone based call centers are still kind of valued higher. And here is one of the survey which McKinsey did in last year, right. They covered like 4 different age groups, right, like all the Gen Z, millennials and so on, right. So they have selected those set of users and they ask questions, right? Let's say you purchase the product or service and you are trying to solve your problem through the self-service mechanism, and you are not able to do that. So what kind of channel, you will prefer, right? So they ask for each and every channel, and if you can see this data, right, the first one is the phone based call center support, right? It's still on the higher side, even though it's a very old way of taking care of supports, right? So there is still very it's very important function for any in any companies to have customer support through phone, right? And when we have a phone based call center system, right, typically in any organization that will be headed by the customer support team, right? And they usually face there are many call center management systems. They are available in market. They are called contact center systems, right? So there are many solutions available in the market which helps organization to manage that conversation, right? How do you route to right agent, record all the conversation, have supervisors also listening to the call conversation and so on, right? But often their requirements are like they come up with specific problems, right? So here are some of the key problems or challenges which they want to address, right? One of them is like identifying customer sentiments and pain points, right? So when an agent talking to a customer, right, agent is doing a good job in solving the customer's problem, but with the overall calls, right, it is very important to get the sentiments of the customer, right? Sometimes, right, you create a new, you build a new release of a solution or which is it's a service or a product, right? And then suddenly you are getting lot of calls and the sentiments are going low, right? So this is the way the data that we capture through call center is the way to figure out how customers are kind of feeling about our new release or new product, right? So it's a very important data, and they need some kind of analytic solution to do that, right? Second is agent performance and quality, right? So usually in contact centers, you have different ways to monitor the quality. You have some systems they provide supervising as well, where your call center, agents are calling, there is always a supervisor on top of an agent, and they randomly get into the call, listening to the call. They don't talk, but they listen to the call, how the agent is handling, and they on the sampling basis they provide feedbacks, right? So that is a live supervising the calls and providing quality feedbacks. Second is all this call whenever you call any call center, they say like this call is recorded for quality purpose, right? So you have a proof, right? So that call recordings are persisted, and then on sampling basis they validate how the quality is, right? So that was the usual way of doing it. But if I want to do it across all the calls, right, how do we do that? So basically consistency in monitoring the quality, that is very important. Another thing is the root cause analysis, right? So customer is calling support center, and then something went wrong, right? Then somebody need to do the root cause analysis. Why that customer felt bad, right? Or he was frustrated, or the sentiment was low, right? So somebody needs to do that root cause analysis, right? So how do we if my support center I am getting thousands of calls, I may not be able to focus on each and everything manually, right? So you need some kind of analytic system which can does the root cause analysis for us, right? Another thing is as I said, all the call center recordings and data, it's like a medium to connect with the customer. After, it's more like after sales, that is the way you connect with customers, right? So it is very important how customers feel, what problems they are facing, and that feedback is actually passed back to the product team or service team to improve their services, right, or product. So that is also one of the important aspect, like how do you get insights, and that can be passed to passed to the product or service team who can work on the improvements. Second is another reason is the volume of calls, right. As I mentioned, one of the scenario like where you have one release and suddenly number of calls increase, right. So that's a gauge like how we can reduce those number of calls. So based on that input we can figure out like there are standard ways which we can provide in our self service mechanism or educate customers, so that ultimately the number of calls reduce, and then it will reduce the cost as well, because we do not need a larger support centers. And then obviously all this along with that, like the managers need to have some kind of a good way to look at all these things in a dashboard or a visualization tool where they can analyze all these things, right. So they need a tool like that, right. So considering all these challenges, we have basically built Versal IQ, which is utilizing all the Snowflake native features. So it's a completely natively built solution. Now I'll talk about the solution. So Versal IQ is the idea is every contact center system you have you will have a recording of each and every support calls, right. So that they are persisted in contact center system, right. So the idea is like once you have your calls recorded stored in your contact center system, and you have some metadata like when the call happened, who was the agent, and any other metadata, right. So right now we are taking only few metadata information like who was the agent and when the call happened, right. So along with this audio file and this metadata, that data is kind of pushed into the Versal IQ, and then we basically from the audio recordings and the metadata we basically create we get insights out of it using the AI ML features, right. And here we are using all Snowflake ML as well as Snowflake Cortex LLM and Snowpark container service to build this solution, right. So part of it we have sentiment analysis. So we do like based on the call recordings we do sentiment analysis, like at the end of the call whether customer was happy or the customer was frustrated. So we have various sentiments which we track, and then we also figure out like why it was negative. If it is negative, what was the root cause of it, right. We also gather all different analytics like problems they were discussing and so on. I will showcase that in the demo, but that is one part, like sentiment and content analysis. It's completely automated, like the contact center system just push the information audio and audio files and the metadata, and then everything runs automatically, generate the analytics and present it in a app. It has a visualize along with the sentiment analysis we also do summarization as well, like what was the summary. I may be talking to the the agent may be talking to customer for 20 minutes, but there is only few things they have discussed. So how I can have a summary which I can later analyze it, like what are the today's summary for all different calls and all. I can do that using visualization, right. So that's the overall features of the solution. I will showcase more in the demo, and basically the benefit is like it will help improving the customer satisfaction, because we are tracking, like let's say based on the analytics I have, right. If some customer was negative because of some reason, I get to know about it through this tool, I can immediately have some targeted offers to that customer, like if you are unhappy, but I mean we are sorry for that, we are giving you a voucher for some other things, right. So that way we bring back that customer to the brand, right. We make sure that customer stays loyal, right. So that kind of approach we can take and improve the customer satisfaction. We improve the first call resolution, right. So the idea is like, if I have that insight, my strategies will be to make sure that in the first call itself customers problems are resolved, right. So agents are well prepared to answer in a right way. They are trained based on what kind of questions coming up from clients and so on, right. The next one is improving the efficiency of agents. Obviously, with this kind of insights, it will help agents to be prepared and their efficiency will be improved, and we can handle more calls with a very specific information that we have, and reduce average time, right. So if we know the insights, we can continuously improve, and we can reduce the overall time for each and every call, because sometimes we know, like if customer is asking this, I'm ready with that information, I don't need to, I mean I can prepare knowledge base based on the insights, right, and it will help agents to be faster to resolve the queries, right. So these are the features and benefits of Versal IQ. So from the use case perspective, for any organization, there is a VP or director of customer support. He is looking for solving this typical challenges, right. So one is quality oversights of calls. So continuously monitoring all the calls from quality purpose, and then based on that take necessary actions. Training agents or providing feedback to agents and so on. Second is knowing more about customer satisfaction. So as the scenario where you have a product release or service release, and then suddenly problems are increasing, right. So you immediately get to know about such scenarios, right, through the sentiments in the calls, right. So continuously having that customer satisfaction surveys done through this kind of analytics. The third thing is identifying common customer issues. So based on this insight, we figure out what are the common issues that customers are facing, and provide that inputs to the engineering team, so that they can improve our products or services, or improve the self-service mechanism, so that customer themselves can solve their problems, right. So these are the three key aspects. Considering this use case, we have implemented our Snowflake based solution, which has a comprehensive quality monitoring, because we are monitoring each and every audio call. So the contact center system pushes all the audio recordings, and we do that analytics on all the audio files. Second is assured customer satisfaction, because we are monitoring and the sentiments of each and every call, and based on that insight we can ensure that customer satisfaction is met, like we take necessary action based on the negative feedback and all. And then streamlined issue resolution, how we can reduce the number of issues coming up in support calls, right. And the overall impact is, it will help in quality improvement, it will reduce the cost, it will improve the customer experience as well. So based on this we can take care of this, right. So this is about the use case. Now coming to the solution architecture. So the idea is like any contact center system, so that is out of the scope of Versal IQ. It pushes the information, pushes the audio files into S3 bucket or any other external stage supported storage, right, in Snowflake. So they push this metadata file as well as the audio files into the S3 bucket. It is configured part of the external stage in the Snowflake, and as soon as the files are there, there are scheduled tasks which will basically launch a Snowpark container service job. So, in the Snowpark container service job, we have multiple steps. So, first step is we need to convert the audio file into a textual transcript. So, we use here the OpenAI Whisper model, which basically helps you to convert the audio into the textual transcript. Second is some of the analytics which we have is speaker diarization. So, when two people are talking, right, this concept is like to separate the script, separate the transcript from both, I mean if there are two speakers, then separate the transcript by each speaker, right. So, speaker 1 talked about this, then speaker 2 talked about this, right. So, I want to get more meaningful text, who spoke what, right. Then I can I need to separate that transcript, right. I want to figure out like how was the tone of customer, how was the tone of agent, I can derive if I have the diarized transcript, right. So, that is where we do the speaker diarization. So, again here we use both combination of OpenAI Whisper and there is a model called piannode.audio. So, the piannode.audio model basically it what it does is based on the audio it will give you segments like from 0 second to 1 0 second to 5 second speaker 1 talked, then from 6 second to 8 second speaker 2 talked about it, right. So, likewise it will give us the segment, then we separate according to the segment we separate the audio and have a diarized transcript for the whole call conversation, right. So, for that we use these two models. So, this all happens in a Snowpark container service job, right. So, after this these two steps, right, we have a textual version of enhanced version of my transcript, right, audio transcript. So, I have a textual content, then we are using Snowflake Cortex LLM. So, Snowflake Cortex LLM, I mean Kamesh presented that function, right, like you have complete function. So, we are using complete and the other functions, right, to capture like to do the summarization, to do the sentiment analysis and to extract some information from the call like what problems they were discussing and so on, right. So, that is how we do that analytics and then persist this particular data back to Snowflake table, and then we have here Streamlit application which is again installed in Snowflake only, where we have a dashboard where it showcase like about the call summaries and all those things, right, which I will showcase. Okay. So, that is about the overall solution. Maybe if you have any question we can talk at the end of it, like you can note down. So, now let me showcase the demo. So, this is a Streamlit application deployed in Snowflake as a Streamlit app. We are going to, I mean we are in the process of converting into a Snowflake native app as well. So, it's loading. Okay. So, the first step what like in the native app what we need to do is, right, in this MVP version what we have here is some of the settings which we need to configure, right. So, this is not okay. So, basically here in the settings we have a couple of metadata that we need to configure, right. So, let us say this is configured for a retail retail company, right, like for their e-commerce portal for example, right. Then I may have specific problems that customers generally ask. I do not want to identify n number of problem through LLM, like because if I ask LLM it can give me the result which may not be relevant. So, I want to track specific set of problems which customers might be facing, and I list down and I can continuously update as well, right. So, here I define all my different problems that customer might have, right. So, that is a metadata which I just add one time, right, or I can update it every time, like there is a new type of problem which is coming up, then I can just track it, right. So, that I can basically check cluster the problem, like specific problem which I want to analyze, right. So, these are all the list of problems, like for example, customer has an account issue, there is a communication lapse or pricing issue, right. So, all those issues I just configure it here once. Same way, lot of time customers call for just inquiries, there is no issue, but they just want to know, like where is my order, when it will be delivered, right. So, some kind of inquiries, like to know some information, right. So, again here also I am creating all different type of inquiries which customer can make, right. So, this is all the metadata I just need to configure, and once it is configured, as in the architecture I explained, right, when the audio files are there, that analytics will use this data to figure out, like whether in this call any of this problem or any of these inquiries are discussed, right. So, I gather that analytics when the background the job is executing, right. So, once that job is executed, right, it will showcase like data for a particular duration. So, here I have start date and end date. So, I can select like during between this date show me all the calls, right, and then it shows like total calls, like number of calls during this duration, like 30 calls are there, and overall total time of each all the calls is around 1 hour and 55 minutes, and then here we see the week wise, like number of calls, like so I can see the trend of number of calls happens over the week during between these dates basically which you have selected. Then we have a sentiment trend, right, weekly, like what was the sentiment, right. So, out of all the calls, how whether it was positive, negative. So, for sentiment we are actually deriving four different sentiments. One is positive, one is negative, then neutral leaning towards positive, neutral leaning towards negative. So, these four different type of sentiments we are capturing from the audio from the call data, and then mark each and every call, and then here in this trend we are considering if it is neutral, but leaning towards negative, I am considering it is negative only, right. So, that is how it shows the trend, and you can see here, like suddenly the negative trends are increasing, right. So, if we have made some, like if it is as it is a e-commerce company, then I may have released new version, and then suddenly people are facing problem, my sentiments are going negative, right. So, I can get that information from this trend, right. Here it shows each and every sentiment wise the number of calls, right. Then I have top 5 problems here listed, like over all these calls, what are the top 5 problems, right, which customers were reporting, and what are the top 5 inquiries they were reporting, right. So, each and every call we have marked, like in this call they have discussed this problem, in this call they have discussed this inquiries, right. So, I have that data, and based on that we are showing top 5 problems which we can focus, like these problems we can solve through some communication to all the customer, right. If you are facing this problem, you do this and you do not need to call us, right. So, that way we can reduce the call based on this analytics, right. And again this graphs here basically showcase the what was the, like when there is a positive sentiment, what was the problems, when there was negative sentiment, which are the problems they were discussing, right. So, we some more analytics which can help us to take some calls, right. And then in the below it will show you all the calls during that duration in the form of table, and we can filter by sentiment, we can filter by problem or inquiries, right. And in this table it shows, like the sentiment status, like green and red. It shows when the call happened, who was the agent, the duration of the call, and then we have summary of the call here, right. It might be 2-minute call, but just showing in 3 sentences what was the summary of the call, and then what was the sentiment, right, in the textual format, like neutral or positive, negative, right. So this is the overall summary dashboard, and then we can deep dive here. So for example, this is a negative call, right. I can click on this detail button, and it will show me the detail view, where I have like more details of that particular call. So who was the customer, who was the agent. So it has identified the customer name from the call itself, then your which file, audio file it is, then the duration, then here we are showing like how overall in 2 minutes, like how much customer spoke, how much agent spoke, like from the time perspective. Again summary, what was the resolution customer agent has provided, so a summary of a resolution, and then this is the overall transcript here, right. And then we can also play the audio and just to verify it as well from here. On the right hand side we see the sentiment, like as it is showing customer sentiment is negative. Then we have further bifurcation, like how was the tone of agent like, and how was the tone of customer. So here you can clearly say the customer tone was frustrated. So that's the reason it has marked that particular call as a negative call, because customer was very frustrated, and he was and these are the reason for this sentiment, like delay in the order, or and the second one is in a frustration with the customer service, right. So these are the two reasons because of which it is negative, right. And then again here it shows all the problems and inquiries that were made. Here below we can see that diarized transcript, like it's just like a step by step speech, right. First a customer spoke something, then agent spoke and all, right. So we have diarized transcript, then we just have only what agent spoke completely and what customer spoke, and then this is the raw data that we have in the form of JSON. So in case I want to pass this information back to the contact center system, so that it can basically have some features in part of the contact center system, they can activate this analytics into their system, right. So this is the overall part of the call summary, and again we can see another one, maybe some neutral as well. So this is negative, then we have neutral, negative as well. So if I open this, right, so it's like again here in this case also it is frustrated, but like the agent provided the answer. So at the end it the overall tone was frustration, but like at the end agent has provided a solution. So it is marked as a, I mean customer was okay, but not like really happy, right. So that kind of analytics it is showing here. So this is about the Versal IQ, like the solution. Okay. So how much time we have? We have 15 minutes, right. So I can show you another solution quickly in 5 minutes, like not in the length of this Versal IQ, but just to give some idea in terms of another document analytics solution which we have built, and then we can open up for the Q&A. Okay. So the another solution we named it Aurora, which is a document analytics solution. Okay. So this is a generic solution, but the use case that we have implemented for any legal department in a bigger organization, right. So usually in the legal department of an organization, you have a number of different type of agreements, right, you sign up, right. So there are multiple scenarios, like one is when you have a legal contracts, right, you want to at an organization level, you might have defined certain you have defined certain rules, right? Sorry. For example, so we have configured it for a contract on legal analytics, right. So, you have legal document like lease document, right. So, any lease that Anblicks as a company is doing, right, anything which they take on lease, the minimum term should be 5 years, right. So, you define certain organization level rules and you want to weight your contracts because everyone is signing up contract different department. You want to make sure that they fall in that line, right. So, second use case is I want to basically I have already signed the agreement, but then there is some event happen and I want to check against that event whether I am whether with this particular contract am I liable to pay something extra because of this event, right. So, I want to check that. So, in normal case you read through whole long contracts and try to figure out, right. So, the way we have done is we implemented this using Snowflake Cortex LLM. So, where there are two set of things. One is we are extracting some information from the document, we are validating some rules against the document, and then we have a chatbot which help you to ask any questions. Okay. I will quickly show you the demo. From architecture perspective, it is very similar to that, except here we are not using Snowpark container service, it is purely using Snowflake Cortex LLM and Snowpark. Okay. There is no container service required in this because I already have the textual format of the document. We are using here RAG, basically the concept which was explained earlier, right. The same concept we are using, we are using RAG mechanism here for chatbot. I will just show you quickly. So, it's loading. Okay. So, again here also we have some preferences. It's not visible. So, here as a first step, right, as we have built this as a generic solution, you need to first define your document type, what you want from the documents, all the legal document, what you want to extract, what you want to summarize, what rules you want to check, right. So, that is more about the details which we want to extract from or summarize from the document, right. So, here for example, a lease document, right. So, we have defined like these are the different document fields from any lease document I want to extract, right. I do not want to read through all document, you just extract this information and out of that some of those fields you show it on the dashboard as well, right. Second is out of this whole document I want some of the section to be summarized, right. So, licensor and leaser and leaser, right, just summarize what is the detail like address and all those things, right. So, summarize those sections, right. I do not want to read through whole document. So, I provide what I want to summarize and then I provide like some of the organization specific rules, right. So, for example, term length, the length of the lease agreement. So, we are saying it should be minimum 5 years. I just define it in a simple English, right. All these things we have defined it in a simple English. Based on that, behind the scene we are generating prompts and using Snowflake Cortex LLM, we are using Llama 3 as a model and then extract that information, right. So, once these documents are defined, it will again read as and when the document arrive in your external stage, the Snowflake task will be triggered and it will extract the information, store it in the database and then in the application we will present that data, right. So, that is one part of it. Another functionality which we have a chatbot. So, for that what we do is each and every PDF document, first we will convert the PDF into text, then convert that into chunks and then create vector out of it, store that vector data in in Snowflake itself in the vector data type, and then we basically like when from the chatbot when any question is asked, first we query the vector DB, figure out like all the similar context, pass that context to the LLM model and then get the answer, right. I will show you how it works. So, this is the summary page where you can see all the documents, number of documents and type wise, like how many documents are compliant, non-compliant. We have defined those validation rules. Based on that, it will mark like whether it is compliant or not compliant, right. So, if I go here, I can see like these are the different type of documents, like so here this is a lease document, right. So, I will just show, I will go here and see the detail why it is non-compliant, right. So, here in the detail page it shows all the summaries which we have defined. I can read through it, what all fields it has extracted, and then below are the different rules, right. So, here we can see the term length, right. So, document has a 3 years term, while our organization term is 5 years, right. So, that is the reason it is showing it is a non-compliant document, right. So, this is more about providing some analytics on the document. Now, let us say I already signed this document, so I want to figure out some conditions, right. So, there is a chat option here, I click on the chat and it will open a chat interface, just like chat GPT. I can ask any question. For example, what if I make a late payment, is there any penalty? Yeah, so it says like if you make a late payment, you will be charged at a late charge of 3%, right. So, I do not need to read through whole document, it has gone into my specific document and extracted the information in a just like chat GPT, right, but for the specific document. So, that is a document analytics solution. Okay. So, now I think that was what I wanted to showcase. So, the idea was to showcase like how you utilize the features which Kamesh has explained into our specific business applications, right. So, now I am open for any questions. Yeah.
In the first use case, there you have mentioned only the top things, right? Top problems left and right.
Right.
So, are you giving the trending? Means can you figure out what is the trending problems as well?
Yeah. So, that top 5 we are showing, right?
Top 5 means, for example, if it is a internet issues, for example, so frequent disconnects is the problems they are facing.
Right.
But there might be a issue which is slowly started now.
Right.
For example, it is modem issue, let's say.
Yeah.
So, will it be able to categorize?
So, we right now in our user interface, we do not have that component, but we do have the data. So, we can easily create that trending problem wise trending chart as well, right. You want to show like
no, I am asking for predictions.
Okay, prediction right now we do not have. We are not predicting based on past, like if this problem is coming like in future, what do you see, right. That right now we do not have. We can do that as an additional feature if it is relevant, but right now we are not doing it.
Okay, coming to the legal documents and the other things. So, what exactly this is different from what we have in the chatbots or anything. So, for example, if there is a book, if I upload the book completely PDF file,
right,
and if I ask a questions to the PDF, means based on the PDF, it will keep answering.
Yeah, so the good question. So, I mean based on our experience, right, most of the customer, like they are hesitant to use any publicly hosted, this chatbots like Chat GPT or like, because your data is moving out of your network, right? In this case, it's completely within your data cloud, right? I'm not sending my document to any external LLM service, right? I'm just using the Snowflake's own model, right? So in fact, this particular solution we have built it in earlier we built like by using having my own LLM model loaded into my account itself, right. So that was also we have done it, but then the Cortex LLM service has been launched, which is a shared service, but it is within the boundary of your Snowflake data cloud, right. So your data is not moving out of Snowflake, right. That's the one of the key thing which every corporate they want to be sure, like because my contracts are like if I am uploading to Chat GPT, it's going out of my network, right, and how they use it internally we don't know, right. So that's the concern, that's one of the difference which we can say.
Thanks. Yeah, this is regarding the same documentation.
Yeah.
So if a real estate guy is having any documents, like he may be having 100 legal documents,
right.
So some local languages and all the things, right. So will he be able to read the local languages, and what extent, like is there any?
Right. So it all, I mean, so we are utilizing Snowflake Cortex LLM, right. So we need to look at which specific model we are using, right. So we are using Llama 3 for example, right. In that also has like different parameter version, right. So if that model supports that particular language, right, we can use it, it can understand.
The same with audio.
Same with like the
audio, like if we are having 3-4.
Yeah, audio, this whisper model, it can detect like language as well, and it supports like set of languages. I don't have the exact list of languages, but depending on which model you are using, right. Like the whisper has like small, medium, large kind of models, right. So I think the large model supports some set of languages, right. So it can detect the language and it can generate the transcript in that language as well. About Indic languages, I am not sure, I need to check, like, but for other English and Spanish and all those, French and all, right, I think it has support.
So that will be converted to English and give the results? Or?
No, translate, you are talking about two things, right. First is audio to text, right. So it will be in the same language. Then second is like once the text is there, then you need to use a translation model, like LLM model, which is specialized in translation, right. So then using that you can translate, right. The whisper is basically you have audio file and you need to convert first into text, and then you use any LLM model to do that, right. So that's why you need to choose the right model which can be better in doing translation, right. Most of these models like Llama and all, they do that, they are good, but there are specific LLM model which are kind of trained for more on the translation as well, right. You may want to use those kind of model as well if you want to translate. Okay.
Yeah, thank you.
Any other questions?
Yep. So this is regarding the document reader. It's on the same context that the brother was asking. Why do we need Snowflake to just read a document? And then your answer was like it's secure. Then we have Llama 3, right? So I can have it in my local environment on my GPU and run it.
Right.
So then why do you decide on Snowflake? What is the importance?
Yeah. So the question here is, it's not you can do it only in Snowflake, you can do it as other, I mean locally hosted environment as well, but like the general practice is like as an organization I have decided Snowflake as my lakehouse platform, right, where I am bringing all my data. I am not just for this use case, I may be using Snowflake as a platform for across my organization. I'm bringing all the data to my Snowflake based lakehouse, right, and then I have various data products created on top of it, right. So, then in that scenario Snowflake is a technology, it is not just a lake house, it provides this analytics in AI capabilities, right. So, I can build the application there itself. So, I am not reading basically one of the concept which Snowflake brought is like you are bringing application to data, not the data to application, right. So, your data is always there in your lake house only, you are bringing your application there, right. So, that is a concept, right. So, if I am using Snowflake as a platform, then this solution makes more sense, but if you are not using Snowflake just for this solution, you may not basically use Snowflake, you can do it without Snowflake as well, okay. But I mean I'm talking in terms of larger context, right? If I am a corporate, I may be on some or the other now all modern data platforms, right, cloud based data platform, I choose one, or sometimes people have multiple as well, right. And then if I have the platform, why should I create a local version of Llama and all manage myself, right, because that's all managed by the serverless service of Snowflake. So, that's where we can utilize this, but if you don't use Snowflake, I am not saying I mean we can do it without Snowflake as well.
Thank you.
We can do that. We have a comparison here. However, we are not utilizing LLM for comparison. It's simple. Our idea was like in the future roadmap we want to do like it's compare like this is, let's say I have version 1 of the contract and version 2 of the contract, and I want to see the differences, right. So, whatever I have extracted, I am comparing that, or whatever the compliance rules I am comparing. But I can do further like with LLM I can even compare in more detail as well, like can you figure out the exact differences and summarize those differences, right, irrespective of what I am extracting. I do not want to see only those fields, but any other things if it has, right, we can do that. Currently we do not have in this solution, in roadmap we thought about it.
Yeah, hi.
And it gives some identity like speaker 0, speaker 1 and all, and then it gives you like 0 to 1 this speaker is speaking, 1 to 5 this speaker is speaking. So, I get speaker 1, speaker 2, then using LLM I am figuring out who is speaker 1 based on that, because I have the text separation, then I am figuring out like if speaker 1 is agent or speaker 1 is customer. So, I get that who is the customer and who is the agent. Then I also check like from this call conversation, can you identify the customer name as well. So, I identify the customer name, and my agent name is coming directly from the metadata, because I need that agent name. I can get it from LLM, but I need that agent name and the call, when the call happened, right. So, then I can trace back, and that information can go back to your contact center system if you want to utilize it, right, whatever analytics we do.
I think we have time for
this is
one
Srinivas.
last question.
Yeah, this is Srinivas. The use case is 2. So whenever you're going to the documents, so we have the multiple documents, correct? There is a multiple linked documents. So if there is any link document missing or there is any naming mismatch, so the LLM will find out like how it will be in general.
Yeah. So you, I mean, if you want to do that, like in your compliance rules which I have mentioned, right, the way you, I mean that's a plain English language, right, I can write that like can you, I mean if this document is non-compliant, if name is mismatch between these two sections, so I just simply write that and it will, through the LLM it can check. I can add that kind of rule in my document in my compliance checks metadata, right?
Okay.
Whatever I want to check.
Okay, thank you.
Okay.
Yeah, the same question. So if we have the document, right, the audio was not completely loaded. Some cases where we face due to the network issue or due to some miscommunication, there is a
Right.
like that. So in cases, do we apply the data quality rules before the data is loaded to the virtual IQ?
Yeah, so that right, we are assuming that we are getting the proper audio recorded from the contact center. We have not implemented any validation, but this is more an analytic solution. We are assuming that whatever data is passed to this system is already kind of curated data, I mean correct data only. If you want to do it, part of our pipeline we can do it, like, because you need to build some pipeline to bring that audio file into this stage, right. So in that particular area, we can implement the data quality check, specific data quality checks we want to do. Right now in this tool we don't.
Yeah, thank you.
Okay. All right.
Yeah.
Okay.
Thanks,
Thank you,
Samir.
everyone. Again, thank you. Sorry, one more question. Last question, because we have to finish the other one.
So this Versal IQ is and there is some market. Are you sharing only the application?
No, right now we have a Streamlit application. We are currently working on Snowflake native app. So we are making it as a native app. So once it is done, because now earlier when we built this, that time Snowpark containers are not part of native apps, right? You cannot have containers part of your native app. Now it is supported. So we are packaging it as a Snowflake native app and publishing in our either private listing or public listing. So anyone, we can, if it is private, then we can share it with customer and they just simply get that application automatically deployed on their account, right. Right now it is, we need to ship the Streamlit code and deploy it on the customer's account, set up the data. We have the scripts and all.
Okay.
But with native it will become more simpler.
Okay. If you guys move it to the Snowflake native application, they just have to install the app in Snowflake. That's all.
Yeah, native app is like you have marketplace. In marketplace, you just select the app. If it is a paid app, then that cost will be charged, right, on the usage base, or different kind of models are supported. So there is a concept called public listing. So public listing is any Snowflake account can see those apps. Second is a private listing, where I have it published in as a native app, but it is not publicly visible. I market it myself, and then customer say that I want to use it, then I can share that application with them. What it does is it will install that application in customer's account, right. So in that case, our code will be secure. It will not be readable to the client, but it will be installed in the client account.
Okay. So do you have any rough idea regarding cost this application,
so there are different models. If you go to Snowflake documentation, now they support any custom billing models as well, right. So you can have billing events, and based on that you can bill, right. So for example, from my app, I can say like number of audio I have processed, right. Based on that I can charge, like per audio file I will charge, right. So I will generate a billing event when the audio file is processed, and based on that I can charge, right. Or I can just charge based on the usage. So if this application is consuming this much of warehouse, right, time, and then or credit, on top of I will charge some credit, right. So that credit will be my additional cost on top of what Snowflake consumption happens. That's another model, but I mean it's a big topic. You can go through documentation, get a lot of idea on that.
Thank you.
Okay. Thank you, everyone. Again, thank you for coming on this Saturday, and we'll go through the next session now.
Okay. We'll take a small pause before the next session, guys. And if you have any further questions for Samir, he'll be on the floor throughout the day. So please feel free to reach out to him. Okay. And yeah, if you want to stretch your legs, just walk around, and then we'll also provide water to you. We'll resume in a few minutes. Snowflake summits. There is no AI strategy without a solid data strategy, right? So our third speaker will be going over transforming data pipelines with the new advanced capabilities of Snowflake. I'd like to introduce Mr. Satish Tirumal Sethi. Some of you might already know him. He is the chapter leader of the Hyderabad Snowflake community, and he's also the Snowflake data superhero. So handing over to Mr. Satish.
Thank you, everyone. So first two sessions very informative related to AI and ML capabilities. So now we are coming to data engineering, the core of the data strategy. So how many of you are data engineers here? Majority are data engineers. And how many are working on Snowflake? So one quick trivia question. How many different kinds of tables are there in Snowflake? 4, 5, then 7. Any other answer? 7, 8 or 6? Okay, whoever said 7, what are the different kinds of tables? Transient, temporary, permanent, then dynamic, hybrid and iceberg, external and event. So total 8. So in this session we are going to talk about the 3 kinds of tables: dynamic tables, iceberg tables and hybrid tables. So before we get started, a quick introduction. Many of you would already know. It's not moving. It's working. That is. So I work as a senior cloud data architect with Infosys, and I am a Hyderabad chapter leader. I see most of you are joining this meetup sessions for the first time. I'll guide you how you can become a part of a Hyderabad chapter member at the end of the session. I am also a data superhero. If you have any questions on the Snowflake data superhero program, you can just reach out to me at the end of the session. Or if you want to become a Snowflake squad member, there are a couple of people here who are part of a Snowflake squad member as well. Even for that, you can reach out to me at the end of the session. And I have 5 certifications in Snowflake, and I have other certifications in DBT, AWS and all. So I am multi-certified. And I am also a technical blogger. So most of the content, whatever I will be demonstrating today, is already part of my blog. I will give you the resources at the end, or just you can take my Medium page, which is with Snowflake Wiki. Snowflake Wiki is the Medium page. Most of the content, whatever I will be delivering today, is already part of the blog. So I first wanted to start with hybrid tables, because hybrid tables is not part of your free trial account. So most of the people would not have explored it, and even in a paid accounts, it is limited to certain regions. So what is hybrid tables? Let us talk about the concept of a Unistore. So Unistore is a new Snowflake workload that delivers both transactional and analytical work data at a single place. So you can derive more insights within the Snowflake itself. For years, transactional and analytical workloads are managed in 2 different systems designed to manage their primary needs. Now what are the primary needs of these workloads? We use transactional systems or workloads, we call it as OLTP systems, online transactional processing systems, and next is OLAP systems, online analytical processing systems, which we use for analytical workloads. So transactional workloads we use are used for fast simple queries, for single record selects and all, and they give multi-second responses. If you wanted to do the analytics on it, we used to move the data from OLTP systems to OLAP systems, where we do the complex queries, large scale scans. The problem of managing or challenges working across these systems is, now you are creating a data silos, and in order to move from OLTP to OLAP, you have to move the data pipeline, or you need to move the data using a pipelines. So, movement of data again can be painful and there will be a latency. And the third thing is, you will have delayed access for development. Now, having this Unistore is having a modern approach of working both transactional data and analytical data at a single place and a single platform for Snowflake. The best thing is, it gives you high value proposition because you have a simple architecture, you can accelerate the development, and a single platform where you can enforce your governance capabilities. Now, how this Snowflake hybrid tables work? So, Snowflake hybrid tables enable you or empowers you for this Unistore workloads. So, hybrid tables are a new kind of tables where when you write a data into Snowflake, the data is stored in a row store or a row storage, and it is asynchronously stored as a object storage. So, object storage is something where you store huge amount of data as an object storage. So, when you write it, when you create an hybrid table or bring the data into Snowflake, first it gets stored as a row storage, and then it's asynchronously copied into an object storage. And whenever you query the data, it also caches certain data in a columnar format, okay, to enable faster analytics. Now, when you write your query, what is the advantage of hybrid tables? So, you are bringing the data is stored in both row level and an object level. And when you write your queries, Snowflake will decide which storage to access. So, Snowflake is efficient enough to access a row storage or an object storage. So, it depends upon the queries. We will see the demonstration or how your hybrid tables will vary from your normal Snowflake tables. But if you are already working on your normal Snowflake tables like permanent tables, temporary tables or transient tables, you know that Snowflake supports 4 constraints. One is null, not null, then unique. What are the other things? Referential integrity and primary key. These are the 4 constraints, but Snowflake only enforces not null by default. This is not the case with hybrid tables. For hybrid tables, you should have a primary key, okay, which is not at all an optional. It has to be given while creating a table, whereas in standard tables, primary key is an optional. Now, foreign key again is optional both in hybrid tables and in standard tables. So, in hybrid tables, as we already discussed about the storage, the data layout is going to be row oriented with secondary columnarization, whereas in standard tables, it is a columnar micropartition storage. So, coming to the locking, in hybrid tables, it is going to be row level locking, and for standard tables, it is going to be partition locking or table locking. So, partition locking is based, it locks the impacted partitions. Indexes, you can define the indexes on hybrid tables as well, whereas you would not be able to define the indexes on standard tables. Before we go deep dive into the demonstration, first thing is the use cases. When you always, as a customer, right, you always have an option. Like someone was asking previously, why I should extract the values from PDF in Snowflake. What is the need when you can extract it outside the Snowflake as well? Of course, customer is a king, he always has a choice. As a platform, what Snowflake tries to do is, it wants to unify the data in a single platform. Same here, you always have a choice, you can always go with an OLTP system and bring the data to Snowflake for your OLAP and your AI ML use cases. But whoever is starting new, let us say is new client, someone is coming into the data world. Why the client or the customer has to go with multiple platforms, then choose one platform and have all his needs suffice in the single platform. Okay. So, that is where the hybrid tables comes into the picture. And for the existing data, let us say you are already managing some OLTP system. Now, whatever is the new data, whatever you are getting, if you manage or if you maintain within the Snowflake as a hybrid table, the couple of use cases I specified is the customer relationship management, CRM data, and for financial applications and supply chain management. So, having transactional data and analytical data at a single place gives you more power to do faster analytics. You can combine your analytical data with transactional data. So, some of the examples I listed is you can detect and prevent fraud by monitoring spending patterns or unusual access attempts. In financial, you can analyze the purchase history and create a marketing campaigns. Third, in supply chain management, you can predict customer demand by analyzing historical sales data and seasonal trends. Let us quickly check on how hybrid tables are different from your Snowflake tables. Anyone have already explored the hybrid tables? Raise your hand. Anyone explored hybrid tables? So, for this all this content whatever I am demonstrating again is part of my blog. I will give you the reference to that again at the end. Let us say I am creating a department table. So, in a normal Snowflake table, when you create a department table, it gives you an option to create a primary key. But does it enforce the primary key? It does not enforce the primary key. Whereas in hybrid table also you can create a primary key. Let us see whether it enforces. So, before a simple demonstration or to set the context, if I create the same department table without hybrid, let me show you what does that enforcement means, whoever are new to this Snowflake. Let us say okay, let me create as let me say I am creating a table called department table underscore sample. I am creating this table with primary key. So, this is a normal Snowflake table which I created. Now, when you go ahead and describe this table, describe table, sample table, you see the department ID is defined as a primary key. Because you defined it as a primary key, okay. Is it a nullable column? It is not a nullable column, though you defined it as a primary key. You created a table called a department sample table, you inserted values and by default it did not become nullable. What is the definition of a primary key? It should have a unique values and it should not have null. Now, though the table says it has a primary key, if I try inserting, let me try now inserting a null and a duplicate value. Let us say again I am inserting 102 and say department 22. Already we have 102 in my department table sample, but still you can insert a duplicate data. See, the constraint has been not enforced, though you have defined a primary key in a normal Snowflake table. You can see there is a duplicate data, and when I described, I can see the department ID is a primary key. But when you create a hybrid table, it follows the attributes of your primary key. you cannot insert a duplicate data and it cannot have nulls. Let us see. Let me go ahead and create it takes some time. So, if you see, right, it is taking certain time for me to create an hybrid table. The reason why it is taking time is I am using CTAS statement, create table as select statement. It has to create a table and insert. So, the best practice when you create an hybrid table is create a table and then insert the data separately. That will give you better performance. So, the table is created. Now, if I go ahead and describe the table, you would be able to still see that the primary key is 5. Now, let me do the same test on this department table. If I try to insert a duplicate data, it says a primary key already exists. Basically, you are not able to insert a duplicate data. If I try to insert a new department ID, I did not change the value. If you try to insert a new department ID, it takes it. So, your hybrid table enforces the primary key which is needed for your transactional workloads. Similarly, you can create, I am creating another table called an employee table, where I am going to have an employee ID, employee name and department ID. I am defining a primary key on employee ID and I am defining a referential integrity on department ID from a department table. You can do this in a normal table as well, referential integrity, and like how I demonstrated, normal tables do not enforce the primary key, they do not enforce the foreign key as well. But whereas here in hybrid tables, they enforce the foreign key as well. And additionally, I am creating an index on an employee name. You can see I am creating an index on an employee name. Let me create this table. Now, let me insert the values into an employee table. So, our understanding of hybrid tables is clear. Whatever your normal tables are not enforcing, your hybrid tables do enforce. Now, let us do a couple of tests. Can you create an hybrid table without a primary key? It is not possible. Every hybrid table should have a primary key. Example, if I try to create an employee table 1 without a primary key, it says hybrid table must contain a primary key. Now, couple of things. You can see whatever the tables you created, you can see the hybrid tables created under show hybrid tables. Whatever the indexes you defined, you can see in the show indexes, and more details about the constraints, you have a table constraints. What are the constraints you defined, you can also see in the table constraints. Now, let us test the constraints. This I have already demonstrated. If a primary key already exists or the department ID already exists in a table, you will not be able to insert the same department ID. I have, let us also test the foreign key. So, what is the significance of foreign key? So, foreign key is, it establishes a relationship between the employee table and a department table. So, if you want to insert a record into a employee table, let us say with a department that is not there in the department table, it should not allow. Or if you want to delete a department, okay, from a department table which is being already used by an employee table, you should not be able to do that, because both the tables you have established a differential integrity. Now, what I am going to do? I am going to insert into employee table using a department ID that is not part of a department table. If you try to do it, I am going to insert, let us say, see I am getting an error saying that foreign key constraint on department ID was violated, because simply the only reason is I do not have 105 department in my department table. If I change it to 101, it will work, because 101 department already exists. Similarly, if you are deleting something from department ID, let us say 103, that is being used in an employee table, you will still not be able to delete it, because that key is being referenced in an employee table. So, whatever the constraints, whatever you see in your OLTP workloads, everything are enforced by hybrid tables. Any questions on hybrid tables? This is a very quick demo. Anyone? What is the? You can't delete. Until you delete it from the department table, you will not be able to delete from the employee table. Yes, you can go with the comp. Yes. Yes. No, your performance will not has any impact, because simply because in Snowflake your compute and storage are different. Okay, both are different. Your storage is different and compute is different. Your storage, of course, your cost is going to be high, because your storage is going to be not doubled exactly, but there is a separate metrics to track the hybrid table storage. Correct, correct. But your performance is not at all going to be impacted. It depends upon.
Repeat the question.
So the question was, will the performance be impacted if you use an hybrid tables? So your performance is not going to be impacted. It depends upon the query. See, if you are writing select star from employee table where employee ID equal to this, it fetches the data from your row storage. Let's say you are going to find the select, let's say number of employees in each department. It's an analytical query. So it takes the data from your columnar storage.
So automatically it converts to the columnar storage.
It fetches the data from the columnar storage. It's not stupid basically. Snowflake itself has started as a cloud data warehousing company. Okay. When it started in 2014, it started as a cloud data warehouse. It was only supporting the data warehousing workloads. Now if you see, Snowflake itself has rebranded itself as a data platform. It's not just the data platform, it's AI data platform. So as a company grows, it became inclusive, how it can reach out to customers in all possible ways.
So these hybrid tables, so are they pertinent to only OLTP you are referring, or the OLAP can
OLAP
be?
also.
Okay.
So basically you are storing the data once, or you are bringing the data once. You can use the same data for your OLTP workloads and OLAP workloads.
Will not be there any latency, because the transactional data is to come into OLTP in a streaming way, but we do the OLAP later on, right? When we mix both of these, won't be there any latency?
There will not be any latency. That is because you are having it at the same place. And when I say asynchronously happens, let's say you are bringing one record, okay? By the time it gets converted into a store, object storage, it may be few seconds.
Okay, thanks.
But you need not again talk about bringing the data using an ETL or ELT or ETL approach, then do the transformations, manage the data in the data warehousing, all that thing you can save.
Okay.
querying the OLTP data is also the costly, right, in Snowflake. What is the use case and in cost?
When you say about cost, right, cost remains same as how you use your warehouse. So, in costing is nothing but the amount of time your warehouse is active. Even when you are querying, even when you are running a select star from table where let us say we call this as a point lookup queries. Okay. So, it depends upon how you are maximizing the usage of the warehouse. The cost, the aspect of the cost remains like how how Snowflake costs you, bills you.
Generally, suppose SQL database, Azure SQL database is a OLTP platform, and Azure SQL warehouse or Snowflake warehouse is the OLAP platform. This just I am asking in the cost perspective.
See, there is no apple to apple comparison, right? In SQL, it's an on-premise. You already procure.
No, Azure SQL database.
Azure, okay.
Then my question is the cost between Azure SQL database, SQL Server database, and the Snowflake hybrid table, which is going to handle both OLTP and OLAP. The cost remains same or huge? Just approximate comparison.
The compute cost entirely depends upon the usage. But in Snowflake, the hybrid tables is going to cost you a bit more because it is going to store in both row level and object storage. There will be a bit more cost.
Because of it reduces CTL work.
Correct.
Okay, thank you.
Yeah. One last question, then again I will open up at the end.
Hello.
Object format is nothing but columnar. No. How much performance degradation we are assuming? Is there any performance? So when you write the data will be written into a row level storage, and it converts asynchronously to an object storage. So writing is not going to have any impact. Yes. How do you do an update in OLTP systems? You are going to do an update even in an OLTP system, it's a row level storage. Whatever is the performance impact it will have, same impact you will have in Snowflake as well. But when you do an update, that is why we will apply a filters, right, where on how you update a limited data set. Else the comparison or the performance comparison will be similar. Here also you are doing, right? So indexing and updating will be like performant on like row level storage. Correct. If you do that on columnar, right, it will be really difficult. But it will not do in columnar, right? It is storing the columnar. When you do an update, the update happens at a row level, and it synchronizes that data into a columnar storage. So there is a latency there when you do that on the. No, at a row level when it is updating, there will not be any latency, right? Only that synchronization for analytical workload only will have a latency, which is better than getting the data of the latency to bring the data from a different system. That is what I am saying. Based on the query, Snowflake will decide which storage to do, and updates and all, that is for select statement, but updates and all will happen at a row level storage. Rest of the questions I will take it at the end. Next set of tables is the dynamic tables. Dynamic tables are new normal now. Previously last year and all they are new, but now they are in a they are for general availability, and everyone has started using this dynamic tables. So dynamic tables are a declarative way of defining your pipelines in Snowflake. Now, what is an advantage of dynamic table? We will make it cut short. Okay, what is an advantage of a dynamic table? Previously, if you wanted to schedule something, we used to use streams and tasks. Okay, for performance aspects, we used to create a materialized view. So materialized view has lot of constraints. You cannot do a joins. Okay, you have to do it on a single table, you cannot do a window, you cannot use a window functions, lot of constraints. Streams, and that is with respect to performance. To build a data pipeline, we used to use streams and tasks. The disadvantage is it's time consuming. You should be aware of streams, you should be aware of tasks to build the pipelines. Now, easily if you want to build a pipelines, that is where the dynamic tables comes into the picture. You can have a DAG kind of a data pipelines using this dynamic tables. So, you have table A, table B. Let us say once you want to get the latest data from table A and table B or refresh, you need not create a task. Whatever is the change data, incrementally you can create a dynamic table called a dynamic table. So, these are the easiest way to build a pipeline. Now, I want to zoom, sorry. Now, as I said, right, most of you, anyone worked with the data modeling, you should be aware of slowly changing dimensions, right, SCD1, SCD2 concepts. Now, because dynamic tables has been introduced, have your streams and tasks became absolute and materialized views became absolute? Not at all. It depends upon the use case. So, the use case is your dynamic tables picks the data, whatever is the incremental data, and it refreshes into a target table based upon the lag you specify. Using that, you can only build the SCD1. You can't build your SCD2 and SCD3 using the dynamic tables. If you want to have a control of how you want to manage your historical data, for sure you should go with creating streams and scheduling via task. If you are only looking at a performance aspect for a reporting where you wanted to store the data, even then you need not go ahead with the dynamic tables, you can go ahead with your materialized views. Okay. So, still materialized views and streams and tasks are relevant, it depends upon your use case, but to easily build a pipelines, we go with dynamic tables. 5 minutes, 10 minutes, 5 minutes. So, I am going to skip the demo part, but if you want to quickly see how you want it, like how to create a dynamic tables, I will just quickly show you. So, you can create a dynamic table with a dynamic table keyword. You need to specify which warehouse to use. Sorry, it is being shared. Okay, sorry. Yeah. If you see, this is a simple create statement specifying the dynamic table. You need to specify the lag, in what frequency you want the data to be pulled incrementally from the source tables. Okay. Now, if I wanted to show you sample dynamic tables lineage, if you go to the monitoring, you have a dynamic tables, you can monitor your dynamic tables from here. Let us say I have customer sales data dynamic table. You can see a DAG here. You can see I have some Custinfo sales data. You can see I have customer info table, sales data table. Based on these two tables, I have customer sales data. Then I have a sales report built on prod, stock, inventory and customer sales data. Like this, you can build a DAG using a dynamic tables. So, whatever is the refreshes, let us say I have certain refresh history. You can see your refresh can happen incrementally. Okay, whatever is the change data in the sources, you can bring that data into your dependent tables. This is on dynamic tables. I will take the questions at the end. Now coming to the iceberg tables. How many of you worked with open file formats? Anyone worked with open file formats? Okay, less people. So in most of the architecture, right, you don't want it to bring the data into Snowflake. Someone was asking about a cost, right? Okay, why I wanted to bring the data into Snowflake? If you wanted to go with the open lake architecture, you wanted to process the data from the files itself. Okay, now to process the files from to process the data from the files, we already have an external table. You can create an external table. The disadvantage of external table is you do not have a metadata to get a good performance, because the data is as a files and you are accessing the data from the files. And if you wanted to bring the data for very good performance, you have to again bring the data into Snowflake using a copy command from the files. Then you get a good performance. How do you get best of both? Using iceberg tables. Why? Because now instead of storing the metadata in Snowflake environment, you store the metadata in the files. Why metadata is important? That optimizes your performance. So this is the use case. You wanted to go ahead with the open lake architecture, and if you wanted to get the best performance, this is when we use a hybrid tables. So Snowflake options, Snowflake supports two options, catalog options. One is Snowflake managed and other is externally managed. Now what is the difference? So in Snowflake managed iceberg catalog, Snowflake provides the platform support where it manages the life cycle. The only disadvantage is it is only read only. You can only read the files. You cannot, So it supports your catalog. In Snowflake catalog, the compute resources is used of Snowflake compute for all the processing. Let us say you wanted to use the compute externally. We have externally managed catalog. Okay. When I say externally managed catalog, you can use glue and all, okay, to write the data into the storage and then read the information from Snowflake. This is the externally managed catalog. Now the life cycle, if you see, you should have the files in an external volume like a blob storage like Amazon S3 and all. Then you create a catalog integration to read the files from the blob storage. If you are using an externally managed catalog, then you should also, that is when you should create this catalog integration. Once you have this external volume and catalog integration, you can create an iceberg table. Again I am saying catalog integration is only for externally managed catalogs, not for Snowflake managed catalogs. So this is how we create our iceberg tables. Again we use this key column called iceberg table. We specify from where to access the data. If you are using an external catalog, then you need to specify the catalog integration, and then you can specify the path from where you wanted to access. Now if you see, once you create your iceberg tables, you will have, let me maximize it. So once you create your iceberg tables, you will be able to see the metadata file and manifest file getting created in your external volume. Okay. So this manifest file and metadata file enhances your performance whenever you are accessing the data from your external volume. So this is about dynamic tables and iceberg tables. Any questions on dynamic tables and iceberg tables?
Since you are asking like the open source file formats, right? So iceberg is one of the open source file format. So other than iceberg, can we create any other open source file format in Snowflake?
It right now supports only iceberg Parquet file.
Okay, thank you.
Only Parquet files are supported. Right now, it can tend to change.
Because we have Apache only also.
Oh, it doesn't. Right now, everything I say right now because You never know with Snowflake. Any other questions? Any? You can start. It will be a very good business. Right now, it's not there. Basically, both are competitors. He is asking if he can move the data from Databricks and Snowflake without any external. From Databricks. But how do you mirror? You are not directly bringing it to Databricks, right?
No need to bring the data. You can just use the database.
Through Unity catalog? Yeah, through Unity catalog, yeah. Oh, you are not talking about open file format. Yes, that can be done. I was thinking about bringing the data directly into Snowflake.
Satish, I have a question on hybrid tables. Okay, you talked about, hello? Yeah, you talked about indexes, right? Is that really required to create indexes on hybrid tables? I mean, why
do we create indexes? For better performance.
No. Generally, Snowflake by default it doesn't encourage to create indexes because it gives more performance.
But at a row level storage, if you want performance, you need to create indexes, right?
Okay, is it? I mean, indexes are really required on hybrid tables. You meant to achieve better performance.
To get better performance, see, very simple. So, in order to answer your question, right? Let's talk about normal table, Snowflake table. On what kind of a data types you have metadata enabled? Anyone knows?
Oh, this date time.
You will have metadata enabled only on numeric columns, date and timestamp columns, not on string columns. For string columns, whenever you query any string column, Snowflake has to access all entire micro partitions because Snowflake do not have information. So, all the micro partitions will be scanned whenever you apply a filter on a string column. But when you apply an index, you can apply an index on a string column. Your performance is getting optimized.
Okay. One more question. We have this Snowflake search optimization, right?
It's another way of indexing, okay? Yeah. But the cost of search optimization is going to be very huge in terms of storage and in terms of managing that search optimization.
My question is
with index, I am just answering. But when you create an index, there is no additional storage apart from that little bit.
Associated for the index as well as cost also, because
storage of index is not going to be high.
Okay, so for search optimization it maintains some indexing also, right?
Correct.
For search optimization Snowflake charges something, right?
There is a high cost for search optimization.
Okay, so that cost is less when compared to this indexing.
Correct. Search optimization is a way of indexing. Record.
Yeah.
Any other questions?
Yes, Satish, I have that here, Satish. So currently I am using the standard tables. So in DBT I am using standard table, but at the same time I am using the increment model. Okay, so while increment model I am using that unique key. So there is one unique key, so nothing but primary key. So instead of using that standard table, so I can go with that hybrid table. So which one is the best way? So the cost wise and performance wise?
No, in your standard tables, it does not enforce the, it enforces the not null alone. It doesn't enforce the unique key, right? So how you are doing it?
So not only null, so I want to avoid the duplicates only. That is my aim.
So right now, how you do is you build an additional pipeline to remove the duplicates and all, usually in the standard process.
Correct.
But in hybrid tables anyway, if you try to insert a duplicate key, it is not going to even allow you to insert.
So that
now, which is the best way is, just because of this use case, you should not create an hybrid table. Just for this use case, okay? You can continue to have your data pipeline where you are removing the duplicates in the following transformations.
Correct. So that again, that will be an additional process. And
additional process. Yes. So only when you have a business requirement. Why? Because if you create an hybrid tables, I only talked about storage. Storage cost is going to high. Even querying on an hybrid tables, there will be little bit of more additional charge for the cloud services layer, because your cloud services layer has to decide whether it has to access a row level storage or an object storage. So, whenever you query in a hybrid table, there is an additional processing cost at a cloud services layer, which you cannot directly see, but you are going to be billed for the access of a cloud services layer as well.
Okay, thanks.
Common table expressions are within the session, right? Only for that query. But when you create a dynamic tables, they are persistent tables. It's an actual table. There is a storage associated with dynamic tables. See, CT is within the session.
Yeah, my question is related to the last one. So multiple businesses have been already associated with this the tables which have some of the redundant data. But if those businesses want to convert to hybrid or iceberg tables in future, we need to remove that redundant data, unless it will not be accepted into the hybrid tables again.
Correct.
So if they want to come into the the futuristic way, what is the approach that Snowflake is taking on there? Just wanted to know, because nobody would want to stay in the past. They would want to come into the future and explore more on top of it, right? So just wanted to know if there is any approach that can remove the redundant data from whatever is the repetitive or the duplicate, whichever is there in the general tables, to the iceberg or hybrid tables.
The only thing is you have to create the tables and then copy the data from normal tables to hybrid tables. That's the only way.
It will not allow, right, the duplicates or the redundant if there are two rows.
If there are duplicates, it's not going to allow. But instead of setting up an additional process, see, in the data warehousing, we get different layers. Okay. So one is a landing layer, data warehousing layer. For sure, if you would have got your data strategy in the data warehousing layer, you would not have got the duplicates, because you would have eliminated the duplicates before loading into the data warehouse layer. So when you create an hybrid table, you should copy the data from the data warehousing layer, where you already eliminated the duplicates.
I'm sure.
Okay.
Yeah. Hi, Satish. Regarding these dynamic tables, you said that it will support the STD type 1, not for STD type 2. Behind the scenes, how it will, the scenario, like is it comparing the timestamp and unique ID? But if there is no unique ID, how the load will be happen?
So based upon the lag, dynamic tables track when the last refresh has happened. So whatever the changes happened after that timestamp in the source tables, it picks that data for incremental load.
But then in the dynamic table, then we will be having a duplicates, right? Maybe if it is not comparing, then
dynamic tables can have duplicates. Yes, dynamic tables is like your Snowflake tables.
Okay. But I'm also using DBT, like there is an incremental model in DBT. So compared to this dynamic and that incremental model in DBT, can we say which one is better? Like is it killing that DBT models?
See, your DBT model is nothing but in the backend it does a merge only, right? If you see the DBT, what it does a merge based upon the
idea and timestamp, yes.
Timestamp or whatever is the column, you define it as a unique key. Correct?
Yes.
So indirectly your dynamic table is not just for incremental load, right? You can do more transformations in your dynamic table. You can join multiple tables, okay?
Yeah.
You can do an aggregations in the dynamic table.
Yeah, and like same we are also using DBT, but perhaps we can use dynamic tables over DBT model.
But when you use a dynamic increment table, still you have to go ahead and schedule the model, right? But dynamic table you need not schedule. It automatically refreshes based upon the lag you specify.
Okay.
Before any questions, I will take it offline. Okay. Now link to the content, I have given a link to my blog. You can check. And whoever has a questions to join the Hyderabad community, please log into that Hyderabad user group, enroll. Future Snowflake events, you will be notified directly from the mail. Okay. Yeah. Thank you all.
Thank
I
you,
will open
Satish.
this slide for some time. You can just.
Thank you, Satish. That was a very informative and interactive session. I would like to invite Abhishek, our VP of Resource Management, to give out some tokens of appreciation to the speakers today. We have a few announcements right after this, and after that we'll break for lunch and networking. If you all can move to the end of the office in a couple of minutes after we wrap this up, that would be great.
Samir is coming actually.
Okay. Yeah. Satish, can you please? We have a surprise feedback option for you later on. Once the event is done, if you can post whatever takeaways you have or the summary of this activity event on our LinkedIn, on your LinkedIn pages with the tags hashtag Anblicks Snowflake event, hashtag Anblicks, and we'll also provide you with the @ of all the 3 speakers today. So if you can tag us in there and then post in your respective networks, that would be great.
Actually, we have a network issue here. That's why we are opening this challenge till 6 p.m. today. So till 6 p.m., anybody we want to in the LinkedIn give a post. So our marketing team will review those posts and they will contact you for the best 3, and they will contact you on the LinkedIn and they will send a surprise for you, surprise gift for you. And some minutes later. Okay, we will have some. Okay, Samir. We'll have one group photo and we'll conclude this one. Okay, and apart from that, I want to say thank you to Anblicks team. Like we wanted to have 1 week before, like due to some issues, we moved this event to this one. And our team like did a very good job. Like I hope you got called 2 times, like confirmation and QR code, everything. So thanks for Anblicks team, everybody. And I hope you enjoyed this event as well. And we are also going to host one more on November. Now one more event on November. So we will post you on the LinkedIn. That is from my side. Okay. We'll have one photo and we'll conclude. I don't want to take more time. Please come this to stage. Our marketing team wants one photo from everybody.
विजय भाई हमें स्क्रीन आप जी विजय भाई